Web 3.0 has the potential to change the internet as we know it forever. You're still early in catching the trend right now and building your first blockchain application. Hi there, and welcome to a project video where you'll build and deploy an online multiplayer Web3 NFT card game powered by Avalanche. Create your characters. Create and join live battles. Choose your battleground and battle other players in real time. With a stunning design, interactive gameplay, smart wallet pairing, live interaction with smart contracts, and most importantly, the ability to battle other players in real time, Avax Gods is the best and the only Web3 online multiplayer card game that you can currently find on YouTube. You might be wondering, what are the prerequisites for building such a fantastic game? You need to know JavaScript and feel comfortable with React. If this is your first time learning Web3, I suggest you watch the Build and Deploy a Modern Web3 Blockchain App video first, and then come back to watch this one. Building this phenomenal game will give you a proper understanding of how to create regular web-based games, but it will also give you detailed insights into the world of Web3, how to interact with smart contracts, pair to smart wallets, and listen to smart contract events. We're going to start easy and then move to more complex topics. I'll explain every step of the way. Alongside building this application, you'll also learn how to connect a regular React.js application to the blockchain and pair it to your wallet. You'll also learn about the Solidity programming language and how smart contracts written in Solidity work. You'll learn how to create smart contracts and decentralized applications on the Avalanche platform. Avalanche is the fastest smart contracts platform out there. It allows you to build fast, low-cost, Solidity-compatible apps. On top of that, with Subnets, Avalanche allows you to build your own custom network optimized to fit all of your project's needs. Subnets will give Web3 games complete control over their own customizable blockchain networks without sacrificing security or decentralization. That allows you to rapidly scale your user base, set customizable rules for your blockchain, and focus on gameplay. Essentially, with Avalanche's help, you'll learn how to create a full-fledged Web 3.0 online multiplayer game and learn the ins and outs of blockchain in a single video. Besides the speed and inexpensiveness of using Avalanche, the thing I like about it the most is its backwards compatibility with existing Ethereum virtual machine tools and workflows. Let me explain. Suppose you have experience creating Web3 dApps for any Ethereum virtual machine, or use tools like MetaMask, Remix, Truffle, Hardhat, Web3.js, Ethers.js, or OpenZeppelin, and more. In that case, precisely the same scripts and workflows will work on Avalanche with no changes needed. Isn't that great? We'll use the most in-demand technologies today, and I'll teach you how to deploy your game online so you can play it with your friends, share it with your potential employers, and put it in your portfolio. If this video reaches 20,000 likes, I'm recording another Web3 video. What I've just showed you might seem simple, but trust me, there's a lot of blockchain and Web3 logic happening behind the scenes. And I strongly believe that building this app is the best way to truly understand how Web3 and smart contracts work. Excellent. With that said, there's just one more important announcement I want to share with you before we dive into the project. Since this is a Web3 heavy project-based video, I've also prepared for you two entirely free Web3 resources. One is a comprehensive Web3 roadmap, and the other is a Solidity cheat sheet. The link to download these resources entirely for free is in the description. On top of that, I've also created a Web 3.0 course in which you'll build an entire fully functional NFT marketplace. This 10-hour course dives into everything you need to know about Solidity, Web3, and smart contracts. Also, since you're watching this video, by using the link in the description, you're going to get a special discount code that's going to automatically be applied for you during checkout. This groundbreaking project will impress your potential employers, making JSMastery.pro the only source of knowledge needed to land your dream high-paying Web3 job that you can enjoy for many years to come. With that said, let's dive right into today's video. To get started, we're going to create an empty new folder on our desktop. Let's call it NFT_card_game. I also opened an empty Visual Studio Code window, so simply drag and drop that folder. Once you do that, we're going to have our folder opened in the most popular code editor out there. So now what we can do is we can go to View and then Terminal. This is going to open up the built-in integrated VS Code terminal. We can also click right here to open up the Explorer, and we are ready to start setting up our project structure. We are going to start this video off with the Web3 blockchain side of things. So to get started, let's right-click right here and create a new folder called Web3. Now, inside of our terminal, we can cd or change directory into Web3. Now, to properly initialize our blockchain side of things, we're going to have to follow a couple of steps and run a couple of commands. But don't worry, I'm going to show you how to do everything step by step. To make things even easier for you, I've created an entire GitHub repository with the finalized code. While you're here, feel free to give it a star. In here, you can scroll down and you can see all the instructions on setting up the Web3 part of the project written step by step. But don't worry, we're going to go through everything together and I'm going to show you how to go through every single one of these steps to ensure that you can follow along nicely. Another great thing we've recently done on the JSM YouTube channel is created a special Discord community. This Discord community is huge, and we are already at over 14,000 members. But that's not what I want to share with you. What I do want to share with you is this special video help section. In here, we're going to have a special forum board for every single one of our videos. So if you're experiencing some issues with the setup, the best way to get help is not going to be through YouTube comments. Rather, it's going to be by creating a new help post in the special video help channel. There, myself, other administrators, and other people will be able to assist you. With that said, let's begin with initializing our Web3 side of things. Once we are in the Web3 directory, we can run the npx hardhat command. You might get prompted to install hardhat. In that case, simply press Y and press enter. Once you do that, we can choose TypeScript, but no worries, no TypeScript knowledge will be required. For hardhat project root, simply press enter and press enter one more time. There we go. This just initialized a project inside of our Web3 directory. If you scroll a bit up, you can see that we need to install some dependencies to run the sample project. So let's simply copy this message right here, paste it, and then press enter. This is going to install a couple of dev dependencies. That's going to take just a moment, and I'll be right back. Alongside those dev dependencies, we're going to also need a couple of regular dependencies. So let's run npm install, add open zeppelin /contracts .env, add nomic labs /hardhat-ethers, and you can press enter. These dependencies installed really quickly. If you want to be sure to get the right ones, you can simply copy this command from here as well. There we go. We can clear the terminal. Now we have installed all the important dependencies we're going to use for the Web3 side of things. The next thing we have to do is install the browser wallet extension. That's going to allow us to interact with the blockchain through our browser. Our application will be written in Solidity, but we'll be using Avalanche to build the app faster and at lower costs. So it's going to allow us to launch those Ethereum dApps even more quickly with transactions happening instantly. Because of that, we'll be using Avalanche's special Core Wallet. Core is a MetaMask alternative for Avalanche dApps. The application you'll build today will work just fine with the MetaMask wallet. But since we're building on top of Avalanche, Core is going to be much faster. And since we're building a game, we need it to be as interactive as possible. That's why I decided to use the Core wallet. To get the Core wallet on the Chrome browser, you can simply go to Chrome Web Store and then search for Core. If you're using another browser that doesn't support Core yet, I would suggest switching to Chrome, at least for the purposes of this video, because Chrome also allows us to have multiple accounts, which we'll have to use to test the online multiplayer game functionality. So it might be a good chance to switch to Chrome. If not, if you really want to stick with another browser, in that case, you'll have to use MetaMask, so keep in mind the transactions will be a bit slower than on Core. With that said, I have entirely removed Core from my browser, so I can guide you step by step on how to install it. So let's click Add to Chrome. It's going to automatically open up this window, and you can click Create a new wallet. You can click I agree. In here, you can enter your wallet name. I'm going to do something like JS Mastery. You can choose your password. I'm going to go with something really simple. And you can agree and acknowledge and click Save. Now, in here, you're going to get your secret recovery phrase. This is the most sacred password there is when it comes to blockchain wallets. Of course, on mine, there won't be any real funds, so I can show it to you. But keep this one to yourself. Write it down somewhere because we're going to need it to initialize our wallet. I'm going to copy it, save it somewhere, click Understand, and click Next. Now, I'm going to paste in the URL here what I copied so we can see the words, and it asks us to verify the secret recovery phrase. So let's select the word that comes after mule. Let's find it. It's going to be sick. Word that comes after nuclear is going to be picture. And a word that comes after shallow. That's going to be safe. And let's click Next. There we go. Our wallet is here. And let's just click the Extensions tab. And let's pin it for easy access. There we go. Our wallet is now here. We're going to set it as a default wallet as well. Perfect. Now, what we have to do as well is open the extension. Click the settings right here by clicking the hamburger menu, go to advanced, and then turn on the testnet mode. This is going to allow us to interact with test networks. Great. Now we need to fund our wallet from the AVAX faucet. To do that, you can click the link down in the description. It's going to lead you to the faucet.avax.network. You can choose the network Fuji C chain, AVAX as the token, and you can click Connect. It's immediately going to prompt your wallet, and you can click Approve. And just click Request to AVAX. There we go, transaction successful. And in just a couple of seconds, if you open up your wallet again, you should be able to see 2 AVAX right here. It is so great that we got the tokens really fast. When you install Core, it's most likely going to give you a lot of messages. So you have to click this icon right here, go to Console Settings, and then click Selected Context Only, because that way you can filter out all of the Ethers related messages. Now we can go back to our Visual Studio Code, and we can create a new .env file inside of the Web3 folder. So that's going to be .env. Again, make sure that it is inside of the Web3 folder, as we're going to have another env for the client side. There, create a private _key variable, and for now, we're going to leave this empty. Now, in here, we'll have to put the private key of our wallet. So here's how to get it. Open up the Core extension, click the hamburger menu on the top left, go to Security and Privacy, click Show Recovery Phrase, and then enter your password. Once you do that, it's going to show you your recovery phrase. Again, keep this to yourself. You need to copy it, and then you can head to wallet.avax.network. Again, the link is going to be down in the description. Click Access Wallet, choose mnemonic key phrase, and paste your phrase right here. Immediately, you'll be logged into your wallet, and in here, if it's not selected already, choose the Fuji test network to be connected to it. Now go to Manage Keys on the left side sidebar and click View C-Chain Private Key. Finally, copy it. Now we can go back to VS Code and you can paste it right here, equal to your private key. Great. Now we have funds and we're connected to our wallet. We can close this, open up the folder, and go to the hardhat.config.ts. In here, we have a basic configuration. What you can do right now is go into the description of this video and find a GitHub gist I provided just for you. There, you'll be able to find a new and updated hardhat.config.ts, and you can simply paste it right here. This hardhat config contains a bit more settings to make sure our app is deployed properly on the Fuji test network. On top of that, I've also included some comments right here explaining how to deploy this contract later on your own subnet. Initially, the decentralized application you're going to build in this video will be deployed on the C chain of our primary subnet on our testnet called Fuji, and we can see that right here. Eventually, as your app grows, you will probably want to move it to your own subnet. If you want to learn more about subnets, why would you ever need to deploy on a subnet, or how would you deploy on a subnet, then you're going to find these links incredibly useful. Essentially, the Fuji C-Chain testnet is great for developing, but as your app starts growing and you start driving a lot of transactions and gas fees, then it might be a good idea to migrate to a subnet. Inside of the first link, you have a lot of information on when you might want to use a subnet versus a C-Chain testnet. And inside of a second link, you have complete documentation on how to accomplish that on your own. Essentially, transactions on the C-Chain might take about 2 to 10 seconds. The ones on the subnet will be much faster. Also, on C-Chain, we're relying on the AVAX token to confirm transactions. But on the subnet, we can create our own token. Essentially, you will be in complete control over the network and its inner workings. And I've also left out the structure to put it on a subnet right here in case you want to do that later on your own. Great, that's going to be it for our hardhat config TS. Now we can close that and we can go into scripts and open up the deploy.ts script. Inside of here, you can see some demo code that hardhat created. Again, down in the description, in that same GitHub gist, you can find the updated deploy.ts script, and you can simply paste it here. It is as simple as creating a new contract factory right here, and then deploying it. After we do that, the only thing we want to get is the address of the deployed smart contract, which is the only thing that this deploy script does. Great. And to finalize our Web3 side of things, of course, the most important part is missing, and that is the contracts and, of course, our smart contract. We're going to delete this log.sol as that is a demo smart contract, and we're going to create our own called avax gods.sol. The smart contract created for this application has about 500 lines. And I don't simply want you to copy and paste what I'm typing for 500 lines. So again, in that same GitHub gist in the description down below, there's going to be a complete avaxgods.sol smart contract. As you can see, it is a long contract and it has a lot of code. But don't worry, we're going to go through everything together and I'm going to explain all of the most important functionalities. I was thinking about this for a long time. Would I want you to simply copy every character I'm writing for these 500 lines? Or would I want to connect this to the front end and then come back and reference the smart contract in places where it makes sense? That way, we can come back and explore specific functions exactly where we're using them. That way, we're still going to explain all of the most important functionality, but you'll also be able to see what it does on the front end and how it behaves. In my opinion, you're going to learn about events, about constructors, functions, and everything so much better if we show it how it's already written and then explain over it. Hopefully that makes sense. On the other hand, if you'd like me to create a complete course where we go in depth about writing this smart contract by hand, you can let me know down in the comments. And if that's something you would be interested in and you need it right now, then I have phenomenal news for you. Just recently, we published CryptoCat, an entire NFT marketplace application course. Inside of this 12-hour course, you're going to create your own blockchain-based marketplace application where people can discover, create, purchase, and sell NFTs. And the best thing about it is that everything is written in Solidity from scratch, which means that you're going to master Solidity by creating an entire smart contract from scratch. You're going to learn how to leverage and test smart contracts, harness the power of blockchain, and use it on a real Next.js application. It has beautiful designs, and you're going to learn how to create Explore NFTs page, listed NFTs, my NFTs, and how to upload your own NFTs to the blockchain. So one more time, if this is something you would be interested in, the link is going to be down in the description. And because you're watching this video, you're going to have a special, unique YouTube discount code. So feel free to check it out. With that said, now that we have our smart contract, our deploy script, and our hard hat config, we are ready to deploy the smart contract to the blockchain. And as I've said, don't worry, we're going to come back and explore the functionalities of the smart contract in depth as we're implementing them on the front end. To deploy our smart contract, we can go to View and then Terminal. First, we need to compile it. So let's run the npx hardhat compile command and make sure that you're in the Web3 directory. This process is going to take a couple of seconds, and I'm going to be right back. And there we go. The contract has been compiled. Finally, we need to deploy the smart contract on the Fuji testnet by running the command npx hardhat run scripts /deploy.ts -- network space Fuji. This process usually takes about a minute, and your smart contract is going to be deployed. I was wrong, it actually took about 5 seconds, and here it is. Now, there is one more important thing we need to do, and that is save the address of the deployed smart contract. So for now, let's simply safely store it inside of the .env. So let's say contract_address is equal to, and let's put it here. We're going to use it later on the client side to access all of the functionalities of the contract. And also, later on, we're going to use the contract ABI, which is right here, to be able to fetch all of the functions on the client side so we can call them and we can manipulate with the data on the smart contract. Great. With that said, we're done with the Web3 side of things. But as I've said, as we're developing the front end and integrating the smart contract, we're going to come back many times to the smart contract to check things like create battle, create different players, and actually work with the game functionality. We're going to explore all of this code as we're developing it. With that said, we're now ready to create our front-end side of things, and then we'll be able to connect the two. To make initializing and starting up our client side a bit simpler, I prepared a client starter folder for you. That's going to allow us to really quickly get you up and running, and then we can focus on what matters, which is building out the application's logic, creating the UI and UX, and finally integrating it with the Web3 smart contract. So down below in the description, you can find a link to a zipped version of the client starter. Simply download it, unzip it, and then you can come to the File Explorer, right-click, and then click Paste. Finally, we can rename this to something like Client, which is the client side of our application. If we expand our client, we can see that this is a regular React.js application built using Vite. Vite is a new and modern Create React app alternative that is a lot faster than Create React app. In here, I've also set up a basic tailwind configuration with some colors that we'll be using, background images, and a font family. Alongside that, there is a package.json that contains just a couple of dependencies. As you can see, we'll be using packages like ethers and the Web3 Modal to make the Web3 integration possible. Then we'll be using the React modal to show some information on the screen. We'll be using the React parallax tilt and the React tooltip to make things a bit more interactive. And finally, we're using the React router DOM to, of course, create routing. Now we can dive into the source folder to explore the app in more depth. Right here, it seems like there's a lot of things happening, but all of these are mostly just empty folder with basic starter files. So let's look into the assets folder first. In here, I prepared for you all background images, all sounds like attack, defense, and explosion. They're going to be used throughout the application. And I've also prepared for you attack and defense icons, as well as all of the cards that there are. So this is going to be an interesting video. But as you can see, there is a lot of files, so I needed to make sure that you have everything to be ready to get started with coding out the logic. When it comes to the components, there is just one component prepared for you here, which is the onboard modal. This is a basic, often used Web3 component that just checks that everything is set up properly. It makes sure that we have the core wallet installed. Also makes sure that we are connected to our wallet and that we are on the right network. And finally, that we have enough AVAX tokens. But since we're fine with all of these checks, we shouldn't see the modal at all, which is why I provided it. To power up that modal, we also have the onboard utils. And even more important, we have a animations.js file, which provides us the explosion animations we'll be using. This is a long file, but this isn't the code that I've created from scratch. I found it on this great CodePen repository. As you can see, this animation has been created by David, and we simply have to click for 8-bit DOM action. So I'm going to click it a couple of times, and this is going to be exactly what our players will see once their cards are attacked. Great. Finally, on top of that, we have a basic homepage, and we have some often used styles we'll be using across our application, like text styles. We have also a higher order component styles, Battleground pages, and regular containers. Great. And finally, we have an index.css file where we're importing Tailwind and the font we'll be using throughout our application. Finally, there is a main.jsx file where we imported the routes or the router from the React router DOM, and right now there is just one route there, which is the home route. Great. Now you know everything there is to know about our current starter folder. To run our application, we have to go to View and then Terminal. Then we have to cd ... to go one directory back, and then we have to cd into client. Finally, we can run npm install to install all the necessary dependencies. This process is going to take just a couple of seconds because most of the things will be coding from scratch. And finally, once that is done, you can run npm run dev, which is going to start our Vite application on localhost 5173. And there we go, a blank white screen that says AVAX Gods Web3 NFT battle style card game, made with love by JavaScript Mastery. And as you can see, I think that now you can trust me that this is just an empty boilerplate folder because there is nothing on the screen, no functionality whatsoever. We're going to code everything from scratch and make it look like this. So to get started, we can now put our browser side by side with our editor. And finally, we can close our terminal and we can go to source and then home. This is going to be our app's starting point. Right off the bat, we're going to start with something phenomenal that not a lot of people teach you. If you check out the finished website, you can notice that we have our homepage. Welcome to AVAX Gods, a Web3 NFT card game. Connect your wallet to start playing the ultimate Web3 battle card game. This is great. But then if we move to /create-battle, you can see that the design is essentially the same. The logo is there, we have a title, we also have a subheading, and we have an image and the footer at the bottom. But what changed is the content for the text right here, here, and then the input inside of the component. So as I've said, I'm quite excited about this part because I'm gonna teach you how to accomplish code reusability in React using higher order components. That's something that not a lot of people teach you. So let's dive right into it. To start creating our higher order component, we can open up the components and create a new file right inside of there. Let's call it page, HOC, like higher order component .jsx. Inside of there, you can run RAFCE to create a basic React functional component structure. If that didn't work for you, you can go to extensions and then type ES7 plus snippets like this. This is the extension you need to be able to run RAFCE. Once you install it, this should work perfectly. Inside of our higher order component, which for now looks just like a regular component, we can import the use navigate hook coming from React router DOM, as later on we're going to use it to re-navigate somewhere. We can also import the logo as well as the hero img coming from /assets. And we can also import the styles as a default import coming from /styles. Great. The difference between a higher order component and a regular component is that as a first parameter, it's going to accept a new component that we're going to pass into it. Essentially, it's going to act as a wrapper for that smaller inside component. We can also pass some additional things like a title and a description. Finally, due to the way we'll be calling our higher order component, we have to add one more function right here. Essentially, it's going to be a function inside a function. You're going to see really quickly how we're going to call it. In here, we can initialize that navigate hook by saying const navigate is equal to use navigate. Finally, let's start creating the layout. First, we're going to have a div that's going to have a class name equal to styles.hoc container. Inside of there, we're going to have another div that's going to have a class name equal to styles.hoc content box. And if you're wondering where these styles are coming from, you can always hold Control and then click on that name. It's going to show you exactly what styles are being used here. And this is using Tailwind. So if you're not sure what py8 or small or px means, you can quickly look that up in Tailwind docs. Just go to tailwindcss.com and search for py, for example. Immediately, you'll be able to see that that serves your padding, and it provides padding y on y-axis, meaning vertical. If you want to search for something else like flex call, let's see, flex-call, and immediately you can see that this is used to position the items vertically. Great. So now you know that you can research any property we're using right here. With that said, let's continue with the layout. Inside of this div, let's also create an image that's going to be a self-closing image tag with a source equal to logo, alt equal to logo, class name equal to styles.hoc logo, and it's going to have an on-click property with a callback function where we're going to simply navigate to just /, meaning the home page. Great. Now, if we save this, nothing is going to happen because we're not yet using this page higher order component. So now let me show you how we can use it. Before we do that, let's export it from our components folder by creating a new index.js file. And then inside of there, we can import it by saying import page HOC from /page HOC. And then we can say export object, and then we can put that component right there. This is now going to allow us to go back into home and then import the page HOC inside of curly braces like this. Import page HOC from /components. Great. So finally, how do you use it? What is the difference between a higher order component and a regular component? Well, a higher order component can wrap another component. And in this case, we're going to wrap our home right at the bottom where the export is. So right here, let's call the page HOC. Let's call it as a function. And the first parameter is going to be that second component, which is going to be the home. Now, if we save this and reload the page, you can immediately see that everything becomes dark and we can see the logo that is coming from our page HOC. But this is not that interesting yet because we cannot see anything else. How can we see this content from the home page as well? That is the custom content, right? Well, to be able to see that, we can go back to page HOC and we can make use of the first prop, which is a component. So right below the image, we can create one more div. Let's give it a class name equal to styles.hoc body wrapper. And inside of there, let's render a self-closing component tag and save it. As soon as you do that, you'll be able to see barely that all of our text appeared right here. Even though it is dark right now, we know that it is there. So how else can we modify a higher order component? Well, we specified that it's going to accept some additional props. So let's pass them. Let's pass an empty React fragment that's going to say welcome to AVAX gods. Let's also add a break tag here, and then we can say a Web3 NFT card game. This is the title. Let's also add another fragment, and in here, let's say connect your wallet to start playing, and let's add a break tag, and then we can say the ultimate Web3 battle card game. Of course, we have to add a comma right here. Great. So now how do we retrieve that data inside of our higher order component? Well, we have the title and description props. So right here inside of the HOC body wrapper, let's go ahead and create a div. That div is going to have a class name equal to flex-row, and w-full. Inside of there, we can render an h1 element that's going to render the title. And right below that, we can render a p element. Keep in mind we're below this div right here. That's going to render the description. Now let's save that, and immediately we can see our text right here. Of course, it's not really styled, so let's apply some styles. To our h1, let's give it a class name equal to, it's going to be a template string of flex. Now a dynamic $ curly braces, styles.head text, and finally head-text. If we save this, this is already looking better. We can now unzoom it. And let's also add the styles to the description by saying class name is equal to $ curly braces, styles.normal text, and also my for margin y 10, and save it. There we go. This is looking great. Let's expand it just a bit. There we go. It looks even better now. And for now, let's remove these three elements as we no longer need them. We have everything inside of our higher order component. Now let's go back into it and let's apply the image as well as the footer as well. To do that, we can go below our component now and below one more div. Let's create a p tag that's going to have a class name equal to styles.footer text. And in there, we can say made with love by JSM. If we save this, we can see it right there. And just to match the theme a bit more, we can change this to made with and then this purple heart right here. And of course, feel free to change this name to your own. Finally, let's get that great image. So below this p tag and below one more div, we can create a final div of this component. It's going to have a class name equal to flex and flex-1. And inside of it, we can render a self-closing image that's going to have the source equal to hero.img. We're going to also give it an alt tag, hero-img, and we're going to give it a class name equal to w-full. On extra large devices, height is full as well, and it's going to be object cover. Now, if we save this, we have a beautiful homepage component. But more than that, it is not just a home. We already discussed that we're going to use the same layout for the homepage, for the create battle page, for the choose battleground page, and for join battle page. That's 3 to 4 different pages that are going to have a similar layout. So let me show you how we can make full use of our higher order component and how we can make things reusable. Let's create a new page right inside of the pages folder called create battle.jsx. For now, we can copy the entire homepage and then paste it right here. The only thing we have to do is change the home in line 5 and 14 to create battle. Inside of create battle, we're going to say something like create br, and then right here we can say a new battle. And under description, we can say something like create your own battle and wait for other players to join you. There we go. And finally, we have to go inside of the main. There, we're going to have to import the create battle. So from the pages folder, let's first export it by right-clicking the page and creating a new file called index.js. There, we can import our homepage coming from /home. And we can also import our create battle page coming from create battle. And we can export both of these inside of a object that's going to look like this, home and create battle. That's going to allow us to go back into main and import both the home and the create battle in one line. Clean and simple, and that's going to be coming from /page. We can now duplicate this route, change it to create/battle, and change the render page to create battle. Now, if we save this, we can manually go to /create-battle and check it out. Same layout, but different text and different elements. If we now go back, you can see the difference. We did this just by literally having an empty component and using a page higher order component. Of course, inside of here, now we can create additional elements such as an h1 with a class name. Let's do text-white and say hello from create battle. Now, if we save this and go to /create-battle, you can see hello from create battle. Let's make that a bit bigger. So text-xl, and we can copy this and put the same thing into home, which is going to say hello from home. And we can now keep switching between the two, which means that we can now have the entire design being the same with almost little to no effort, as this component is already coded out, but we can keep changing what goes inside of these components with the logic and with everything else that is in there. Perfect. I'm really happy that this early in the video, I got to show you the power of using higher order components. If you like this part of the video, go down to the comments right now and let me know. If you do that, I'll try to teach these lectures as often as possible in future videos. Also, if you like this segment, you're gonna love what we do on jsmastery.pro. There we have professional 10-hour plus courses where we dive in depth into React topics just like this one. We have 2 courses right now, the Film Part course, which dives in depth about React, and then the NFT Marketplace course, which takes Next.js and Web3 Solidity development to the next level. Again, I just wanted to put that out there. With that said, we're now ready to continue with the development of our great application. Believe it or not, we're gonna jump right into action. We're gonna close our create battle, home, hire the component, and main, and we're gonna focus straight on the application's context. So we can go to source, and we can create a new folder in the source folder called context. This is not going to be a regular context. This is going to be a context through which we're going to connect our front-end application to the Web3 smart contract. So let's create a new index.jsx file. Inside of there, we can import React. We're gonna also import create context, use context, use effect, use ref, and use state. I think that you can already see that we're using almost all functionalities from React, so this will be a lengthy component and it won't be easy, but we're gonna go through it. We're gonna also import something known as ethers, coming from ethers. This is a package that's going to allow us to interact with the smart contract. We're going to also import the Web3 Modal as a default import, like this, coming from Web3 Modal. As we discussed before, this is going to help us kind of set up the onboarding flow of our application to make sure that the user is properly connected to the application. And let's also import the use navigate hook coming from react-router-dom. Then we can start creating our context. We can say const global context is equal to create context, like this. And then we can say export const global context provider is equal to a function that has just one prop of children, and it's going to have a return as it is a regular React component. Now, what we want to return is going to be a global context dot provider, a component that looks like this, and it accepts one prop, which is called value. This is an object where we can pass all of the values which we want to share with every single component in our application. So right here, inside of the context, we're gonna interact and connect with our smart contract, and then we're going to pass all of those values here so we can utilize them from every single component within our application. Finally, we're gonna also have a helper function or a helper hook called export const use global context, which is going to be equal to a callback function where we're going to call the use context and we're going to pass in that global context. This is going to allow us to call it from other components. As an example, for now, let's pass a demo variable equal to test to our value, like this. And now we can try getting access to that value from our other components. The first thing we have to do is go inside of main, and we have to wrap our entire application with our provider. So right here, we can say import global context provider from /context. And then right here above routes, we can create a global context provider component, and we can put all of the routes inside of it. Let's make sure to properly indent that. There we go. And the routes go inside. Hopefully this makes sense. So what we have just done is we wrapped our entire application with the global context provider. That means that now inside of the home, we should be able to successfully use the demo variable we have created. Now we're going to go back to home page here. Now the reason we can't see our app is because we're not returning anything from our context. As you can see, it is empty. That's why we have to put the children right here, which means return everything that we pass to our app. In this case, that's going to be our home component. Great. Now, as I promised, let's try testing out the context from within our home application. Right here, we can import use global context coming from /context. the only thing we have to do to get that demo variable is say const demo is equal to use global context. And now we can console log it, or even better, we can print it out. So right here, let's create an h1. Let's give it a class name equal to text-xl and text-white. And inside of there, let's render the demo variable. As soon as we do that, we can see test, which means that we're successfully passing the value from our global context provider all the way to our home component. Although passing something like demo is not that cool, so we're going to remove that for now and remove from here as well. What is cool is fetching the entire data from the smart contract and then being able to pass it right here. So that is exactly what we're going to do next. We're going to have a series of use effects which we're going to use to connect to our smart contract as soon as the application loads. First, we need to connect with our smart wallet, with Core. So to do that, let's create a new use state field, which is going to be called wallet address. And at the start, it's going to be set as an empty string. Now let's create a function, const update current wallet address. It's going to be an asynchronous function. And right inside of there, we can say const accounts is equal to await window.ethereum.request. And then inside of there, we can pass the method equal to ETH_request accounts. Now, you might be wondering, what is this Ethereum object on the window object? How does that exist? Well, let's go to inspect. Let's open up the console and let's type window.ethereum. As soon as you do that, you'll see that there is a lot of different variables which we can call. In here, we have constructors, assign, create, a lot of different things is happening here, and that is due to the fact that we have Core installed. Same thing is happening with MetaMask. It injects Web3 functionalities right into your browser. Now, let's try to console log those accounts. There we go. I'm going to open up the inspect element, console, and now, of course, we have to call this function. So let's create a use effect. We're going to only call it at the start, which means that our dependency array is going to be empty. And we're going to call our update current wallet address, like so. Let's save it. Now we get a message that essentially says that we cannot connect yet. And that is because we haven't yet set up the smart contract provider. So let's do that right away. I'm going to create one more use effect, and bear with me, there will be a couple in this index file. So let's create a new use effect right below this one, and it's also going to be called just at the start of the application. So dependency array is going to be empty. There, we can create a new function, const set smart contract and provider. And it's also going to be an asynchronous function. We're going to call that function immediately as soon as the website loads. The reason why we had to create this function and not just write the code here is because it's asynchronous. We want to get access to some async code. So let's initialize the Web3 modal. Const Web3 modal is equal to new Web3 modal, and we call it as a function. Const connection is equal to await Web3 modal.connect. Const new provider is equal to new ethers.providers.web3 provider, and we're going to pass in that connection we established here. Then we need to get a signer who is signing the contract, which is going to be equal to new provider.signer. And finally, we're going to get a new contract, which is going to be equal to new ethers.contract. And in here, we have to pass the data from the smart contract that we have created. But of course, we don't have that data yet. Or do we? Well, we technically do, but it is inside of the Web3 folder, we are yet to pass it into our client-side application. But even with this change done, you can see that we got a core notification, which is great. For now, I'm going to reject this as we're going to connect later on. First, let's inject our smart contract into our front-end application. We're going to do that by creating a new empty folder inside of the source folder called contract. Inside of there, we're going to create a new index.js file. There, we're going to need to export that address we saved before. So it's going to be export const address, and it's going to be equal to an empty string. And finally, we can go back into web3.env, and we can copy this contract address we saved and delete it from here. Make sure to copy the contract address and not the private key. And finally, you can paste it here. There is one more thing that we'll have to do, and that is take the artifacts, contracts, and then copy and paste the avaxgods.json right inside of our contract folder. So simply drag and drop it right here. Then inside of the index, we can import it, import contract from /avaxgods.json, and then we can export the ABI from that contract. So export const inside of an object, ABI equal as ABI in capital letters, or just a colon right here, and then is equal to contract. If you're wondering what an ABI is an application binary interface. It is a context that you can think of as an interface between two program modules. Essentially, it allows our front-end side to call the functions that we have created inside of our smart contract. We need it to properly pair the two. With that said, we can now go back inside of our context and we can actually pass the right values in. Of course, let's first import them. So at the top, we can say import ABI and address, all capitalized, from ... that's going to be contract. And finally, we can pass them right here. New ethers contract. We're going to pass in the address, the ABI, and the signer. That's all that we need to properly create a new contract. Now, what are we going to do with that contract? Well, let's set it to the state so that we can use it later on. I'm going to create two new state fields. Use state. That's going to be a provider. Set provider. And at the start, it's going to be set to an empty string. And also, use state. Contract. Set contract. And that's going to be set to an empty string as well. Finally, we can scroll down and we can say set provider. And we're going to pass in the new provider. And we can say set contract and pass in the new contract, which means that we're successfully setting these values to the state. And as you can see, the update current wallet address, where we request for accounts, now actually is popping up right here. So let's click approve. Great. This means that we have connected our wallet to our application. Now that application is not going to jump in again. Instead of console logging the accounts, let's set them to the state. So we can say if accounts, then set wallet address to accounts 0, because we only want to set the first one. Now we want to call this function on the first reload, which is happening here. And we can also call it whenever we change a wallet inside of core, because core gives us the possibility to do that. So let's say window.ethereum.on accounts changed. There we want to call the update current wallet address as well. Perfect. Now we have set up two different use effects. Since we're going to have many, let's properly document them. The first one right here, which is actually a function being called inside of a use effect, let's put it like this. Set the wallet address to the state. That's what it is doing. And then this one right here, it's going to be used for set the smart contract and the provider to the state. And now you can collapse them by clicking the arrow right here. That's going to make it easy for us to continue developing our application, as we're going to have a lot of functions and a lot of use effects. But great job so far, our wallet is actually connected. This by itself should be enough to pass this data into our home component and start connecting our first user. So let's do just that. If we go to value right here, we can pass our contract as one of the props and wallet address as the second. Going back to our home, we can now get that contract and wallet address straight from the context. I think that you can now see the power of what we're doing. The next thing we have to do is create this input as well as the register button so we can successfully register users to our great game. Let's get started by giving this div a class name equal to flex and flex-call. Inside of there, we want to render two custom components. The first one on the list is going to be a custom, reusable, self-closing input tag. Of course, this component doesn't yet exist, but we're going to create it right now. Let's go into our components. Let's create a new custom input.jsx, and let's run RAFCE inside of there. Let's go into the index of the components. Now, inside of the components index.js, we can export our newly created custom input component by importing it here, custom input, and then finally, we can export it. There we go. Let's save it, go back to the home component, and in here, we can import the custom input component from components. Let's save it, go back to our app, and if you reload the page, you should be able to see custom input right here in black letters. Now let's create a custom state right here inside of the home called player name. That's going to be use state, player name, and set player name right here. And finally, it's going to be set to an empty string at the start. Now to this input, we can pass in a label equal to name. We can also pass in a placeholder equal to enter your player name. We can also pass in a value equal to player name and a handle value change equal to set player name. This custom input is going to be an incredibly reusable component, so we're immediately passing everything as props. And finally, we have to, of course, import the use state from React. There we go. Now we can jump into the custom input component and we can start developing it. Don't worry, it's going to be pretty straightforward. First things first, we have to import styles from /styles. We're going to also create a specific regular expression. So let's call it regex. It starts with a /, then we have a caret sign. Inside of square brackets, we have A to Z, all uppercased. Then we have A to Z, lowercased, and then 0 to 9, like this. And then we can put a plus and a $sign. And we can close it with another /. This right here is a regular expression for all characters that are within A to Z capital, A to Z lowercase, or numbers. These are the only valid characters for our player name. Inside of our custom input, we're also accepting some props, which we sent before, such as label, placeholder, value, and handle value change. We pass those straight from home. Our component is going to be an empty React fragment, inside of which we're going to have a label. That label is going to have an HTML4 property equal to name in a string like this. Then we're going to give it a class name equal to styles.label, and we're going to pass in the actual label in there. As you can see, we have name right here. Finally, we're going to create a self-closing input tag below. Let's give it a type equal to text. Let's give it a placeholder equal to placeholder. Right immediately we can see something, but of course it doesn't yet look good. Let's add a value equal to value. Let's add an onChange property. And that onChange is going to be equal to a callback function where we get an event. But then we have to check if e.target.value is not empty, or if regex.test is e.target.value, meaning does it pass our test of being only a character or a number. Only if that is the case, we can call the handle value change and provide the target value. Now, if you try typing letters or numbers, it's going to work. But if you try with special characters, it's not going to let you, which is exactly what we wanted. Finally, let's give it a class name equal to styles.input. Perfect. This is looking so much better. I'm loving this. Of course, this doesn't yet have functionality, but it will soon. Now, of course, every input also needs a button that does something with that input. So our next job is going to be to go to Home, and right here, we can create a custom button component, a self-closing tag. It's going to accept a title as a prop, which is going to say register. It's going to accept a handle click, which for now we're going to set as an empty callback function. And it's also going to accept rest styles, which are going to be a specific styles for this specific button. And that's going to be set to empty6 as margin top. Now, of course, if we save this, it's not going to work because the button doesn't exist. But let's go ahead and create it. Inside of components, we can create a new file called button.jsx, or rather we called it custom button.jsx, run rafce, and let's also export it from the index. That's going to be right here, custom button from /custom button, and we add it right here. Now, if we go back and reload the page, we of course have to go back to Home and import it from here. Custom button. And there we go. It says custom button, but it's not yet custom as we didn't style it. So now let's go into the components folder and let's open up the custom button and let's jump right into it. The button is going to be even simpler than the input. Inside of here, we can import styles from /styles, and we can immediately accept all the props we passed, such as title, handle click, and rest styles. And we can make use of them. We're going to return a simple button component. Button is going to be of a type is equal to button. It's going to have a class name equal to a template string that's going to say styles.btn, as well as rest styles. And finally, we're going to give it an on click equal to handle click, and let's pass in the title. As soon as we do that and save, you can see the register button right here. Now, it seems that our rest styles are not being applied because we cannot see that margin top. So let's go back to Home, and rest styles, looks like I typed rest type. This right here was supposed to be rest styles. And there we go. Now we have a beautiful homepage with an input and a register button. But of course, we're just diving into action, as now we have to implement the handle click for our register button to actually register our user. And that, ladies and gentlemen, will be our first interaction with the smart contract today. I've showed you how to set the smart contract up and deploy it. I showed you how to create higher order components and initialize this great application, but now we're actually interacting with the smart contract. We can set ourselves up for success by creating a new handle click function. Const handle click is equal to async function like this. And now finally, of course, we can call it when we click the button, so we can pass the handle click right here. Phenomenal. Let's make our first interaction with the smart contract. To start interacting with our smart contract, we're going to create a try and catch block, because sometimes the requests we try to make from the front end aren't going to be successful. So we have to properly catch those errors. For now, let's simply alert the error right here. And later on, we're going to create a proper error handling with a modal that's going to pop up and say, hey, you have an error. But more importantly, what's going to happen if we are successful? So right here, we can create a new contract call by saying await contract dot is player. We call that as a function and we provide a wallet address as a parameter. So now, how did I know that? How did I know that there is the isPlayer function and that we have to pass the wallet address as the parameter? Well, finally, now is the time that we're going to go back to our Web3 side of things. We're going to open up our contracts and open up the avaxgods.sol. In here, we're going to use the Control or Command F, and we're going to search for isPlayer function. Let's see where is it declared. In this case, it's going to be the first instance of its occurrence, and that's going to be on line 66. So let's explain it. Function isPlayer, which accepts a parameter of type address, which is called ADDR. It is a public function, which means that we can call it from outside, and it's going to return a Boolean. So we know that as well. If player info, when accessed by this specific address, is equal to 0, that means that the player under that address doesn't exist. So we're going to return false. Else, we're going to return true. Okay, this is quite simple to start with. So now we can go back. We know that this function is returning a Boolean. So we can say const player exists is equal to await contract.isPlayer. Great. And I'm going to make this just a bit bigger so everything fits in one line. And we can collapse this as well. There we go. So now we have a variable that lets us know if a player under this address has already created a player account. So we can say if no player exists, in that case, we can call a new function. In this case, GitHub Copilot autofilled it for me, but let's write it one more time. Await contract.register player. We're going to pass in the player name. That player name is coming from this input that we created right here. Let's see what else do we have to pass to this function. So one more time, we're going to go back to the contract and we're going to search for register player. Line 150. It accepts a couple of different parameters, a property called name and also a property called game token name. So let's pass that as well. In this case, a game token can be the same as player name. That's totally fine. And we can go back to the smart contract and explore what this function does. First of all, when you see require in Solidity, it is some kind of a check, a statement that can throw us out of the function call. So in this case, we want to require that a player is not already registered. And we can do that by calling the function we saw just before, the isPlayer function. So right here, we're saying if not isPlayer, message that sender, meaning the one who is trying to make this call, then we're going to say player already registered. If that is not the case, we can proceed with the function. And in here, we're going to give it an underscore ID, where we're going to give it an ID equal to the current number of players. Then we're going to push a player to the players array by creating an instance of a player with the player's address, a name, and then the values of 10, 25, and false. What are these values? Well, let's control or command click the player. And in here, you can see that that is the player mana and player health and the Boolean variable that says, are we currently in battle? So going back, mana is 10, health is 25, and then we are not currently in battle. Once we push that player, we're going to simply create the player info mapping, and we're going to also automatically create a random game token, and most importantly, we're going to emit a new player event. That is the most important part of this register player function, because we'll be able to listen to the new player event on the front end, and then we'll be able to fetch it and then do something based on that event. Perfect. Now that we know that, let's go back to home and let's finalize this function. Of course, we have to show something to the user while this function is being executed. So now might be the best time to create our alerts, both for errors and for successful messages. So let's go back to our index, our context, and right here, let's create a new use state. That use state is going to be called show alert and also set show alert. And at the start, it's going to be an object that's going to have a status equal to false, meaning it's currently not showing, type equal to info, and also a message equal to an empty string. Now we're going to scroll down and we're going to create one more use effect. So let's say use effect. This time the callback function is going to have something in the dependency array, meaning it's going to change based on one parameter. And that parameter is going to be show alert. In here, we can check if show alert question mark dot status. So if the status is currently true, meaning the alert is showing, then we want to create a new timer by saying const timer is equal to set timeout. That is going to be equal to a callback function. And there we want to set show alert to be equal to status false. Type info and message is an empty string, meaning we're canceling it. And that is going to happen within 5 seconds. So right here, to close the timer off or to close the set timeout off, we can say 5,000. So what this means is we are going to show the alert, of course, but we want to close it after 5 seconds, which is why we're using a timer. In React, when you're using a timer, you want to also return, and then you want to clear the timeout by passing the timer. It is always good to clear all the timers when you're setting them inside of use effects. Great. Now that we have the show alert and set show alert, we can pass those values right in our context. That's going to be show alert and set show alert, which means that we can use them inside of our home component right now, simply by getting them from the top. In this case, we're going to need only the set show alert, and we're going to set it right here after our await is done. So right here, we can say set show alert. We're going to pass in an object. Let's pass the status of true, as we do want to show it. Let's pass the type equal to info, because we haven't yet registered the player. We're just registering it. So we want to show some information and not yet a success message. And finally, let's also provide a message that's going to be something like a template string, player name is being summoned. There we go. This is great. Now for error messages, I had some problems with this. Error messages are going to come in a weird format and we have to parse them before showing them on the screen. So let's give it a shot. Let's try to purposely get to an error here. I think we'll be able to achieve that by entering the name, like test right here, clicking register, and there we go. Contract.isPlayer is not a function. So in this case, we get an error that I wasn't expecting. This right here says that there is no isPlayer function on our contract right here. So let's reload the screen. Let's try it one more time. And yep, still the same thing. So let's debug it. I'm going to add a console.log statement right here, and I'll try to console log the contract to see if it is really there. I'm going to open up inspect element, and I'm going to put it at the bottom so we can better see it. I'm going to clear it and reload the page. It seems already that we're getting an error right here, and if we proceed with testing, yep, still the same thing. New provider.signer is not a function. And that is happening inside of the set smart contract and provider. So let's go back to our index and let's search for the set smart contract and provider use effect. In this case, I made a typo. Instead of signer here, we need to put get signer. This is going to be good. Let's save it. Okay, we still get this error, but now if I type test and click, okay, there we go. Now we get a different error right here, which is good. A different error always means that you've done something. It says resolver or address is not configured for ENS name, argument name, value invalid argument. And in the console, we did get the contract, and that contract seems to have all of the functions that we can call. One of them should be isPlayer, and we can see that it is there. Let's also check out our initial function right here, update current wallet address, window.ethereum.request, and right here, I misspelled method. So that's why it couldn't request accounts. Let's simply go ahead and switch this to method, reload, and everything seems to be great. So now let's give it a shot. Let's try to enter the player name, click test, and again, we want to test out the rejection right here. We want to test out the errors. So I'm gonna click reject. And we do get an object as the error. And as you can see, we get code 4001, and there is the message. User rejected the error. And also we have original data and original code. There is the message we want to extract. This message seems pretty straightforward, so we can do it manually. If we go back to home, and right here, we can use the same setShowAlert. We can take it, and in this case, status is going to be true, type is going to be error, and then we can put the message to be equal to, we could do, what is that, error.data, or no, just error.message. So right here, error.message. Great. Now we are properly setting the alerts right here, but we don't yet have a component that would display them. So that's going to be our next task. Let's delete this console log and let's create a new component inside of the components folder. Let's call it alert.jsx. Inside of that alert, we can run rafce and we can import the alert icon that's coming from /assets. We're going to also import styles coming from /styles. Our alert is going to accept two things. A type, is it success, info, or error? And of course, it's also going to accept the message. Our alert is going to be a div that's going to have a class name equal to, now bear with me, it's going to be a template string with styles.alert container, as well as styles.flex center. Inside of that div, we're going to also have another div that's going to have a class name equal to, again, a template string of styles.alert wrapper, as well as styles, and then inside of square brackets, type, because we want to show a styles for info, success, and error, depending on which one is it. And finally, we can render the alert icon, to which we can pass the type, equal to type. And next to it, we can pass the message. That's going to be it for our alert component. We can now export it right here from our components. That's going to be alert, and also at the bottom. Finally, we're going to go back into our page HOC because we're going to be using this across our entire application, and that's where we want to import our alert. Inside of here, we're going to use something from context. So we can say import use global context from /context. We can get something from it right here. Const show alert is equal to use global context. And based on that, right here below the inner opening div, we can say if show alert (status) is truly, meaning just exists, then we want to show a self-closing alert component. We're going to pass in a type equal to show alert.type, and also pass in a message equal to show alert.message. There we go. So now if we reload this, it's going to say that we have to import the alert component. So let's do that. That's going to be import alert from /alert. And there we go. It seems to be already showing, although there is no message. So now let's go back. Let's go all the way back to our homepage or rather the context of our application. The status is initially false, so that should be good. And let's check, are we setting it to true somewhere? In here, it's also false, so it shouldn't be showing. If we reload, yep, it still seems to be there. What if we try again initiating that error? So I'm going to click right here and I'm going to click reject. There we go. We get the error and the notification seems to be here, at least the icon, but it's barely visible. So there's definitely something we have to fix with that alert. Since it's not being closed, let's go to where we initialized it. That's going to be at the top, and it looks like I set the status to be a string of false instead of a Boolean value. If we fix this, there we go, it's gone. But now if we try to test it out with this error right here, by clicking register and then rejecting, we don't yet see it here. I mean, I see the dark icon, but then this gets back right here. So most likely, yep, the Boolean is here as well as false. So we just have to put it as a Boolean, not as a string. But yeah, it's still not showing the styles as it should. So let's go back to where we call it, which is right here. Status is true. It looks like that's my bad. This was supposed to be a Boolean value elsewhere as well. And finally, a message. I just noticed right here, the type for error is supposed to be failure, as that's how I defined it inside of styles. So failure right here. Finally, let's give it one last shot for this error message. Test, register. I'm gonna reject it, and there we go. Although the message isn't appearing right there, so it looks like it's not getting the error dot message, although it is here. That's why I said I had some issues with how the errors worked. Let's try to console log the error one more time. Alongside console logging the error dot message to see where does it disappear. And let's repeat the process one more time. As you can see, it seems that it just contains the code and nothing else in there. We cannot access this data right here. So what we can do for now is simply right here, create our own message saying something went wrong. And then later on, we're going to dive deeper into how to handle errors. Now, if we test this one final time, I'm going to register and I'm going to click reject. And as you can see, we get a beautiful error message saying something went wrong that's going to go away in 5 seconds. Perfect. Now is the time that we actually test if the success call is working. So we want to successfully register a player. To do that, let's add a real name. In this case, I'm going to do JS Mastery, and I'm going to click register. And finally, I'm going to click approve. We see JS Mastery is being summoned. This process usually does take a couple of seconds. And for now, there isn't really a way for us to check if our user has been created. That is where the events come into play. Because when we register a player, we are emitting a new player event. So we have to go back to our context, and now we have to make use of event listening to be able to listen to what our events are saying to us. To start working with our events, we're going to create a new file inside of the context folder. Let's call it create event listeners.js. Inside of here, we can import ethers coming from ethers. We can also import the API coming from /contract. That's going to be all that we need for now. And we can create a special function called add new event. This function is going to accept something known as an event filter, a provider, and a callback, or CB for short. So what do we want to do with it? Well, we want to, first of all, say provider.remove listener, and we want to pass in the event filter. What this line is ensuring is to not have multiple listeners on the same event at the same time. So before we add a new one, we're going to remove the previous ones. Then once we have removed the previous ones, we can say provider.on event filter, we're going to get the logs right here inside of the callback function. We want to parse those logs by saying const parse log is equal to parentheses new ethers.utils.interface with a capital I, and we pass in the ABI. Go inside of both parentheses and then type parse log. And we of course want to pass in the logs. This is a built-in ethers functionality. Finally, we want to pass the logs as a first and only parameter to our callback function. I know this was messy, but believe me, it's going to make sense really soon once we start creating all of those event listeners. So let's do just that. Let's create a new function, export const create event listeners. It's going to be a function that's going to later on accept a few parameters. For now, we don't have to accept anything. And the first thing we're going to do is we're going to call the const, in this case, new player event filter. We're going to set that equal to contract.filters.new player. So when you create a contract and specify an event for that contract, such as the new player event, you'll immediately be able to filter the calls for that contract. And that's exactly what we're doing right here. Now, this is not going to work right off the bat because we don't yet have the access to the contract in this file. But let's continue with the logic and then we can import the contract through props. So now that we have the filter, we can call the add new event function that we created above. And we're going to pass in the new player event filter. There we go. Finally, we have to pass the provider as the second prop, and then we have the callback function. Inside of that callback function, remember, we're passing the parse logs. So we can destructure that, and then we get args, or arguments for short. Finally, we can console log new player created, and then we can also console log the args. While we're here, why also not show a notification or an alert? So we can say if wallet address is triple equal to args.owner, in that case, we can set show alert. We're going to do a status of true. We're going to do a type of success. And we can do a message equal to player has been successfully registered. There we go. So now we added a new event listeners. But as you can notice, our contract is not defined. Our provider is not defined. Our wallet address is not defined because this function is not within our context. We are yet to call it there. So let's do just that. Above our use effect for alerts, we're going to create a new use effect. This use effect is going to have a callback function. And for now, we're going to leave the dependency array empty. In here, we're going to check if the contract exists. And in that case, we're going to call the create event listeners function. Also, you need to make sure to import it at the top. Import create event listeners from create event listeners. I just noticed I have a typo right here. So that's going to be event right here. There we go. And also update it here. Now we can call that function. And inside of an object, we can provide all of the props that we need to use inside of there. One of the props is going to be navigate. We're going to pass in the contract. We're going to also pass the provider. We can also pass the wallet address. Let's pass the set show alert as well. And that's going to be it for now. Now, if we go back, we're getting all of these values through props. So let's make use of them. We are getting inside of an object, so you need to destructure, navigate, contract, provider, wallet address, and set show alert. Great. This should make our event listeners work. So hopefully we'll be able to reinitialize our player Or rather, should I say, we should not be able to initialize a new player, because under this address that we have registered right here, we already created a player before when we weren't listening for it, but still it was created. So let's give it a shot one more time. I'm gonna reload the page, type in JS Mastery, and I'm gonna click register. But as you can see, nothing happens. That is because in the home, we're already checking if the player exists right here. And it looks like it does. So it's not letting us do what we need to do. And that's okay, because later on, we'll need to test with multiple players anyway. So what we can do is go to your core wallet, click right here under your name, and click add account. In this case, it's going to give me a couple of notifications. I'm gonna close some, and I'm gonna approve my account. Now we can switch back to our first account, and we can click the plus button at the bottom right. Let's send some funds. In this case, I'm gonna choose my account. I'm gonna choose account 2, and let's send it about 0.4. AVAX should be enough. And let's click next and send now. You need AVAX to be able to do any transactions and register the user as well. So let's go to account 2, and immediately we get prompted to connect wallet to the site, which we do want to do. Now, if we reload the page, we should be able to create a new player. So let's try with account 2 in my case, and I'm gonna click register. We do get a notification and we can click approve. But still, we didn't get that notification, even though we know that the player is created, because now we cannot click the register button again. Most likely, the reason why the event listener didn't work is back inside of the use effect, we forgot to pass the contract as a dependency array here. And it is possible that at the time, while we're trying to execute this, while we were trying to set up event listeners, we didn't have a contract right here existent because it was just being set to the state. So once we add this and save, you can notice that we get a lot of errors saying that navigate is not defined. Navigate is a function coming from use navigate, so we can define it at the top. Let's say const navigate is equal to use navigate, and call it as a hook. That fixes the issue, and I'm guessing that the next time we create a new player, we will get a notification. We're not gonna test that out now because we would have to create yet another account. For now, we're happy with those two. Of course, we'll have to create many players as we test the game's full functionality. So now that we do have a player, what is the next thing we have to do? Well, a player doesn't have anything to do on the homepage anymore. We need to redirect them to the create battle page. So let's do just that. Let's go back to home for one final time. And right here below the handle click, we're gonna add another use effect. Use effect, that is going to happen when the contract changes. So right here, we're gonna add a contract as a dependency array. And then we're gonna create a new function, const check for player token. And that's going to be an asynchronous function. Inside of here, we first want to check if a player exists. So for that, we're gonna call the same function we called right here. Const player exists is equal to await contract.isPlayer. And we can paste that here. Then we want to check if a player token exists. And remember, player token is being created at the same time while we are registering them. So we can check for that by saying const player token exists is equal to await contract.isPlayer token, and we pass in the wallet address. That is yet another function inside of our smart contract. Finally, if both a player exists and player token exists, then we want to use the navigate function to go to / create battle. Let's save it. In this case, it looks like use effect is not defined. So at the top, we can import use effect, save it. There we go. We are back. and I'm gonna reload the page. It didn't seem to me that we were redirected. So what we can do is we can console.log player exists as well as player token exists. But of course, it's not happening because we never called the check for player token function. So let's do that right here. If the contract exists, then we want to call the check for player token function. There we go. This is looking good to me. And we do get player exists is true and player token exists is true, which is exactly as we expected, but it looks like we forgot to define navigate. So one more time at the top, we can import use navigate coming from React router DOM. We can define it right here. Const navigate is equal to use navigate, call it as a hook. And now we have it. Let's reload the page. And there we go. Hello from Create Battle. Isn't that great? And now, a cool thing is, if you try to go back manually to /, it's going to redirect you back to create a battle because you have connected your account and also you have a player. That is phenomenal. That means that we are ready for the next stage of our application, and that is allow the player to create a battle. To do that, you can hold Control or Command and then press W a couple of times. Make sure you're inside of your Visual Studio Code to close all of your tabs. If you press Control W while in Chrome, that would have closed the Chrome tab. So sorry that happened. With that said, we are ready to continue working on our app. And we're going to continue right inside of Create Battle. So now we can go inside of Pages and we can go inside of Create Battle. You can see how simple it is now that we use the page higher order component. But you're going to notice that we also created a couple of other reusable components, which are going to be the custom input and the custom button. So now our job is going to be much easier. With that said, let's start working on the create a new battle page. To start creating our battle page, let's first import a couple of hooks from React, and those are going to be use state as well as use effect hooks. We can also import the infamous use navigate, which we forgot so far a couple of times, from react-router-dom. We're going to also import styles coming from /styles. We can import the global context or the hook we created for the global context called use global context coming from /context. And since we already have a couple of components built in, we can import the custom button as well as a custom input component. And let's initialize the navigate variable so we don't forget. So that's going to be use navigate. Great. Finally, let's focus on the JSX side of things. We're going to have an empty React fragment right inside of here. And then inside of there, we're going to have a div. That div is going to have a class name equal to flex, flex-call, and mb-5 for margin bottom. Inside of there, we're going to render a custom input self-closing component. And below that, we're going to render a custom button self-closing component. If we save this, you can see that we get an input and a button. And let's add all of the necessary props, such as label, which is going to be battle. Let's add a placeholder equal to enter battle name. Finally, we'll have to add a value, but we're not going to initialize the state for that value inside of create battle because we're going to need elsewhere in other components as well. So what we can do is we can go to our index of the context and let's create a new use state field at the top. So right here, use state, that's going to be battle name and set battle name equal to an empty string at the start. Now we can pass that value right here through the value of the context, battle name, and set battle name. Now going back to create battle, that's going to allow us to get a couple of things from the context. Things such as the contract, to be able to make contract calls, and also battle name and set battle name. That's equal to use global context, and we call it as a hook. Now we can add the value to the custom input equal to battle name, and we can add the handle value change equal to set battle name. When it comes to the button, we can pass the title equal to create battle. We can pass the handle click, which is going to be equal to a handle click function we haven't yet created, but we can right now. Const handle click is equal to an arrow function. And finally, we can pass rest styles equal to empty-6 to divide it from the input. If we save this, you can see how simple this was, considering that we had pre-built components and a pre-built higher order component. Now we have a home component and a create a battle component. Now to take this even further, we're going to add an additional p tag below this div that's going to say, or join already existing battles. That's another one of our app's functionalities. Let's style that. Class name equal to styles.info text. And on click, we want to create a callback function where we're going to navigate to /join-battle. If we save this, you can see that now we have that as well. But if we click it, join battle doesn't yet exist. So let's create a new page called joinbattle.jsx. And we can, of course, run RAFCE. And let's also export it from our index. So that's going to be here and here. And we can call it join battle. Finally, inside of the main, we can import join battle. And we can duplicate the route. Instead of create battle, that's going to be join battle. And right here, join battle. If we save this, we can now see this join battle text, but it's not yet looking good. But you already know the drill. To instantly make it so much better, we're just going to use our higher order component. So let's go ahead and import a couple of things. We're going to import the use effect coming from React. Let's also import the use navigate coming from React Router DOM. Let's also import the use global context coming from /context. Let's import the custom button component and also the page HOC. And that's coming from /components. And finally, let's import the styles coming from /styles. Great. Now you know the drill. We can simply wrap the join battle with a page HOC. The first parameter is the component itself. The second one is the title. Join BR a battle. And then we're going to create another one for description. That's going to be join already existing battles. And we can also add a comma right here. If we save that and reload, there we go. Join a battle page is now done, which is perfect. Now, if we click the icon on top left, that's going to redirect us back to home. But remember, we have an instant redirect to the create a battle. So now we can switch between those two. Now, inside of here, let's create a subtitle to show the existing battles. Let's call it an H2 element. And let's say available battles, like this. And let's give it a class name equal to styles.joinHeadText, and save this. There we go, available battles. And also at the bottom, let's add a p tag that's going to have a class name equal to styles.info text. And this p tag is going to say, or create a new battle. This button is going to navigate to the create battle page. So alongside importing use navigate, we have to initialize it. Const navigate is equal to use navigate, and we can give it an on click equal to a callback function where we navigate to / create - battle. And finally, we can now switch between the two. Isn't this beautiful? And you can see how simple this is, just due to the fact that we created this higher order component. Beautiful. Great. So now, of course, one player will be able to create a battle and the other one will be able to join that existing battle. So first, let's focus on the create a battle smart contract functionality. To do that, we can close most of the files and go back to the create battle page. There we created this handle click component. So filling it in is going to be our next task. The first thing we have to do is make this function asynchronous because contract interactions take time. Then we want to make sure that the user actually filled in some characters. So we can say if no battle name or no battle name dot trim, then we want to return null. We want to exit the handle click function. Otherwise, we can open up a try and catch block and we can await right here contract dot create battle, and we're gonna pass in the battle name. So now might be the best time to jump straight into the smart contract code and to see how the create battle functionality works. So let's do that by going to Web3 contracts and let's search for create battle. Line 218. Function create battle that accepts a battle name as the first and only parameter. We have two requirements first. First of all, the player must be registered. We have already done that. And second of all, the battle with the same name must not exist. Okay, that's good. Then what we're doing is we're creating a special battle hash. Let's Google what this function does. I'm going to paste it right here. And as you can see, this is an online hash function. It's going to generate specific hash based on some input that we pass in. So if you pass a battle name, it's going to generate a hash of that string. Great. In this case, we're doing just that. We're passing that name. Then we're creating a new battle. We're initializing it. So first of all, we're setting the battle status as pending because a player hasn't yet joined the battle. We are providing a unique battle hash. We are providing the battle name, and we're adding the player addresses. This is the address of the player that created a battle, and then the second player, we're setting it as the address 0, meaning it does not exist, because player 2 is empty until they join the battle. Then we provide the moves. In here, this is going to be a Boolean variable of has the player made the move or not. At the start, both players haven't made their moves, so it's 0. And finally, we have the address of the winner. In this case, it is empty until the battle ends. Then we get the ID of the battle, we push the battle into the battles array, and then we return it. Great. This is all the functionality of creating a battle. And finally, when it comes to errors, for now, we can simply console log the error until we implement better error handling. Now, before we actually test the create battle functionality, I want to create a waiting screen because the battle isn't instantaneous. You don't immediately jump into the battleground. First, you have to wait for another player to join you. That's why we're going to have a special wait game screen. So right here, we can create a new use state called wait battle and set wait battle. And at the start, it's going to be set to false. Then right here, after we create a battle, we want to set wait battle to true. And then based on that right here, we can render a component. That component is going to be called game load. So let's create a new component under components, game load.jsx. Let's run RAFCE inside of there, and let's export that component as we always do. So that is going to be game load. Great. We can now go back to create battle, and we can import it from the top. We are importing other components already, so let's add game load to the list. Finally, right here below this empty fragment, we can say if wait battle, meaning wait battle and end, then show the game load component. If we save that and reload, we're not gonna see it because wait battle is false. But for now, let's set it to true at the start so we can actually see how the wait battle is going to look like. And there we go. Right now, it is a simple string that says game load. Let's jump into it and let's implement the entire JSX of our game load component. To do that, we're going to import use navigate from react-router-dom. We're going to also import a custom button coming from /custom button. We're going to also import use global context coming from /context. We can also import player 01 and player 02, which are coming from /assets. If we control click to check it out, you can see that a player 1, if we find it, is going to be this icon right here. And finally, we can import the styles coming from /styles. Great. Our game load component is going to immediately get the wallet address from the context. Thankfully, we have it there. So that's going to be wallet address is equal to use global context. And we can also initialize navigate by saying const navigate is equal to a call to the use navigate hook. Great. Now let's start with the layout. First, we're going to have a div, and that div is going to have a class name equal to a template string where we have styles dot flex between, as well as styles dot game load container. If we save that, you can see that everything is going to turn in a bit of a color purple, right? That's because we want to show something on top of the screen, because we are waiting for another player to join. Then inside of there, we can have a div that's going to have a class name equal to styles.gameLoadBTN box. And inside of there, we can render our reusable custom button self-closing component. We can give it a title equal to choose Battleground. We're going to give it a handle click equal to navigate / Battleground. Make sure to put it inside of a callback function. And we're going to give it rest styles equal to empty-6. And there we go. Don't click it now because you're going to go away to a page that doesn't yet exist, but we're going to create it soon. For now, let's focus on what matters. Let's create a div below this div right here. That div is going to have a class name equal to a template string of flex-1, styles.flexCenter inside of a dynamic block of code, $ curly braces, and flex-call. Inside of there, we can show an h1 that's going to have a class name equal to a template string of styles.headText, as well as text-center. And it's going to say waiting for a, then a break tag, and then we can add worthy opponent, ... There we go. This is already looking better. We can also add a p tag below, and say class name is equal to styles.gameLoadText. And we can say pro tip. While you're waiting, choose your preferred battleground. There we go. This is quite cool. Later on, we'll be able to choose the battleground which we're going to battle on. Isn't that great? But for now, let's continue with our waiting screen. Inside of this div, below the p tag, we're going to create another div. That div is going to have a class name equal to styles.gameLoadPlayersBox. Inside of there, we're going to have another div that's going to have a class name equal to $ curly braces inside of a template string, styles.flexCenter, as well as flex-call. And inside of there, we want to show an image, a self-closing image tag that's going to have a source of player01 and a class name of styles.gameLoadPlayerImg, like this. If we save that, we can see this player icon appear right there. Below it, let's also add a p tag with a class name equal to styles.gameLoadPlayerText. And inside of there, let's render the wallet address .slice from 0 to 30, just to make it a bit shorter. And there we go. We have our wallet address, so we know it's really us. Finally, below this div containing the p tag, we can create an h2, and there we can give it a class name equal to styles.gameLoadVS, all uppercase. And there we can say VS. Finally, we can duplicate this div above, paste it below the VS, and now we're doing the same thing for the opposing player. It's going to be player02, and instead of wallet address, we're simply going to show a lot of question marks because we don't yet know who is going to join. So something like this should work. Let's save it, and there we go. This is looking great. That's going to be it for the game load component. We can now go back and we can set it to false initially because we're not yet waiting for the battle. We haven't yet created it. So now would be a great time to create a new battle to test out the create battle functionality. So let's enter the battle name. I'm going to do JSM battle and I'm going to click create battle. A new core notification appears and I'm going to click approve. And we got a waiting for a worthy opponent right here, which means that we have successfully created a battle. Now, if somebody reloads the page, the game load is going to disappear, but the battle still exists. And as you can see, that indeed is the case. So how would you solve that? How would you check if the battle is already created? Well, we will need to have an object that's going to keep track of an active battle. So for that, let's move straight into our index.js inside of context. There, we're going to create, believe it or not, yet another use effect. This one is going to be used to set the game data to the state. That's going to be useful later on once we want to map over the active games or if we want to check if the current player is in a game. So let's create a new use effect. And if you're wondering, why do we have so many use effects? If they have the same dependency array, then we could have put all the code in the same use effect. Well, it's always better to stay organized. So simply add a comment above each one and separate them by purpose. And don't just put all the code in one place. It's going to hardly be readable. With that said, this one is going to be executed whenever the contract changes. So right now, let's create a new function, const fetch game data is equal to an async function. And just so I don't forget, let me call it immediately right here, fetch game data. Inside of there, we want to check if the smart contract exists, or we can even do that right here by not calling the function if it doesn't. So if contract exists, then call the fetch game data function. And then inside of there, we want to first get all available battles. So const fetched battles is equal to await contract dot get all battles. Again, how do we know that this exists? Well, let's go back to our smart contract and let's search for get all battles. As you can see, this is a really simple getter function that simply returns the array of all active battles. With that said, let's console log it. Let's see if our battle is there. So console log fetched battles. Let's save it. And let's go to console and check it out. It seems like we're getting an array of 2 battles, but the first one is just 0. Whenever you're fetching some data from the smart contract, the first element is always going to be just empty. So keep that in mind. We start from 1 in this case. And there we go. Believe it or not, JSM battle is here, and we can see the address of the player that created the battle. That is great. We can also see the battle status of 0, which means that it is pending. Nobody has joined yet. Great. There will be some battles that players will have already joined in, but we also want to filter them to show only the pending ones. So if somebody goes to the join existing battles, we only want to show the ones that nobody has joined in before. So let's create a filter. Const pending battles is equal to fetched battles dot filter, where we get a battle as a parameter, and then we want to check if battle dot battle status is triple equal to 0. That means that it is pending. Now what we want to do is we want to find a battle that our current player has created, because that is an active battle. So let's say fetched battles dot for each battle, we want to have an if statement. If battle dot players dot find player, and then player dot to lowercase is triple equal to wallet address dot to lowercase. That means that our player has the same address as the address of the wallet in the browser. In that case, we can do something. So let's open a block, and then we can have one more check. If battle.winner.starts with is equal to 0x00, that means that we don't have a winner and that the battle is still active. If that is the case, we can create a new variable right here at the top. Let active battle, set it to null. And right here, we can override it with the actual battle. So active battle is equal to battle. Great. Finally, we can set all of this info to the state. So let's create a new state field at the top. That's going to be use state. Let's call it game data. Set game data. And at the start, it's going to be equal to an object that has a players array set to an empty array, pending battles array, of course, at the start set to an empty array as well, and it has an active battle, which is at default set to null. Great. Now we can update that game data right here by saying set game data, create an object, pending battles is equal to pending battles dot slice 1. Remember, we want to start from 1. And we're going to also pass the active battle, which we got from the fetched battles. That is great. Now, it looks like we have an error. That is most likely with this if statement right here. So let's see if we're properly closing it. It seems we are, but it seems that something else is off. So let's see what is that. We're properly closing this. The fetch game function. The error is right here. pending battles is actually going to be pending battles.slice and then 1. There we go. So now if we fix that, we're properly updating the state with our game data. We can of course pass that game data right here through our value of the context. And now we can go back into create battle and continue with what we have started. Now, based on this data, we can know if the currently logged in player has created a battle or not. So let's create a use effect inside of create battle. There we go. It's going to change when the game data changes. Remember, we're getting the game data from the context. And there we want to check if game data (active battle (battle status) is triple equal to 0. In that case, we want to set wait battle to true. And there we go. It works. And now if you reload, you can see we're still waiting for a worthy opponent. That's great. We have successfully put one account on hold. Now, to properly test the functionality, we have to implement the join battle as well. So we can do that by switching to our different core account. That's going to be account 2, and we can reload the page. There we go. This player hasn't created a battle, but now is our turn to go to join already existing battles. And right here, we have to list it as an available battle. We haven't yet done that. So now we can close all the files and open up the join battle.jsx. Inside of here, we have to use that new game data to actually list the available battles. To map over the pending battles, we can make use of our context. So right here, above our navigate, let's say const, we can get the contract, we can get the game data, we can also get the set show alert, and we'll need set battle name. As when we're joining, we also need to set that battle name, and finally the wallet address, and that is equal to the use global context. Now below available battles, we can make some space and we can create a div. This div is going to have a class name equal to styles.joinContainer. There we can open a new dynamic block of code and say game data dot pending battles dot length, meaning if they exist. In that case, question mark. So if there are any pending battles, then we want to go to game data dot pending battles dot, and we want to call a dot filter on it. Before we do that, let's also add the case if there aren't any pending battles. In that case, we can show a p tag like this, and we can give it a class name equal to styles.joinLoading. And in there, we can say something like reload the page to see new battles. Great. Now, if we save this, something will be wrong. Let's try to open the console to see what exactly. It seems like undefined is not a function at filter, so we have to provide it a callback function. And if we save, everything is looking good, but of course we haven't yet filtered the pending battles. So how are we gonna do that? Well, we're gonna get a battle, and in here we have to find battles that don't match any that the current player has already created. So we can say no battle.players.includes wallet address. So not the battles that the current player has created. Otherwise, he would be playing himself. Great. So now we have filtered them. And now we have to map through them. So we're going to call a map where we get a battle as well as the index. And for each battle, we want to instantly return something. So use parentheses here instead of curly braces. We're going to return a div for each battle. And that div is going to have a key equal to battle.name plus index to make it unique, and give it a class name equal to styles dot flex between. Inside of there, we're going to have a p tag that's going to have a class name equal to styles dot join battle title. And there we can render the index +1. There we go. So now if we save this, you can see a number 1, meaning there is one battle. And also, next to that, let's render a battle.name. And there we go, JSM battle, a battle we indeed did create. Below that battle name, we can create a custom button, and we can give it a title that's going to say join. Finally, we can give it a handle click. It's going to have a callback function. It's going to call a handle click function. And we want to pass a battle.name to it to know which battle do we want to join. Of course, this handle click is a function we haven't yet created. So let's do that right away. Const handle click is an async function. And that seems to be good for now. So now if we save this, we have one available battle, which is exactly as it should be, and we have a join button. Now the code of the join battle handle click function is going to be similar to the create battle click, but of course there's going to be one important difference, and that is going to be instead of create battle, we're going to join it. First, let's set the battle name to the state equal to the battle name that we're passing through params, as you can see right here. Then let's open a new try and catch block and say await contract dot join battle, and we're going to pass in the battle name so we know which battle do we want to join to. Now let's learn more about the join battle function inside of the smart contract. Let's search for it. On line 242, we can see the join battle functionality. It accepts a battle name as the first and only prop. Then it gets the battle by the battle name. We have to make sure that the battle has not already started, and we have to require that a second player is joining the battle. We cannot join a battle we created. Finally, we want to require that a player that is joining is not currently in battle. After we pass all of these checks, then we can set the battle status to started, and we can set the second player to the player that joined the battle. Finally, we update the statuses of both of these players to true, to be in battle. And finally, we emit a new battle event, which we can listen for on the front end. Great, now we know how the join battle works as well. Once we join the battle, let's also show an alert. So set show alert with a status equal to true, type is equal to success, and finally a message is equal to joining, and that's going to be a template string of battle name. Of course, we have to use backticks. There we go. And for the error, for now, let's simply console log it. So console log error. Great. Now that is done already. But let's not make a mistake that we did when creating a battle. We don't want to join now, and then what happens? We don't know. We want to set up the event listener for the join battle event so that we can properly listen for it and then redirect both players to the Battleground area. Great. To do that, we're going to go to our create event listeners file, and we have to add a second event, which is going to be a new game token. So right here, we can copy the first two lines right here, still inside of the create event listeners right here. Let's make some space. I'm going to paste those two lines. But now, instead of the new player event filter, it's going to be new battle event filter and filters.new battle. Make sure to change this as well. And of course, add new event, new battle event filter, and we get arguments. Now we can start working on the code of what is going to happen once this event is dispatched. Of course, our goal is going to be to navigate both players to the battleground area. And it looks like we forgot the closing parenthesis. Great. With that said, let's get started with the new battle event listener. To get started, we can, as we did before, add a console log right here so that we know that the event happened. So let's do console.log, and let's do something like new battle started. We can also console log the args, and in this case, we're going to console log the wallet address because there are two players. We're going to get one from our own wallet address, and we're going to get one from the arguments of the other player. So now that we know that, let's create an if statement. And in here, we have to check if the wallet address dot to lowercase is triple equal to args dot player1 dot to lowercase, or wallet address dot to lowercase is triple equal to args dot player2 dot to lowercase. So we want to make sure that our player is either a player 1 or a player 2. If that is the case, then we want to navigate to /battle /args dot battle name. Perfect. So we are ready to start with the battle. Finally, once we join the battle, we want to update the game data. So to accomplish that, we can go back to our context. That's going to be the index.js file. And at the top of the file, we can create a new use state field. That use state is going to be called update game data. And at the start, it's going to be set to 0. Now we can take that update game data function and we can pass it to our create event listeners, which is, let's find it, right here. So here we can pass set update game data. And now what we can do is below the navigate, we can set update game data like this. Of course, we have to get it. So let's get it from the parameters of this function, set update game data. And what we want to do there is get access to the previous or prev update game data. And then we want to return prev update game data plus 1. We want to increment that variable. Based on this state, we'll know when we have to reload the battle screen to show new and updated information. So going back to the index, now we can update the game data right here, which is this use effect. More specifically, we can update it once the update game data variable changes. So right here, we're going to pass the update game data as the second dependency parameter. Great. With that said, our event listener is now done. And before we try and join the JSM battle, let's go ahead and create a new battle page. So let's create a new page called battle.jsx. Let's run RAFCE inside of there. And this one is not going to be a higher order component wrapper because this is going to be our game battle page. It's going to be entirely different. So for now, let's first do some imports in there. We can import the use effect as well as the use state coming from React. We can also import the use params as well as use navigate, which is coming from React Router DOM. Then we can import the styles coming from /styles. We can import a couple of components. So that's going to be our alert. And that's all that we need for now from /components. We can also import our context, or rather use global context from /context. And we can import a couple of assets such as attack, attack sound, defense, defense sound, player 01 as player 01 icon, and player 02 as player02 icon. And that's coming from /assets. Finally, we're going to import the play audio function from /utils/animation.js. Great. Now we have all the imports. Let's try to use some of them inside of the top of our component. Let's try to get something from the global context. Things like contract, game data, wallet address, show alert, set show alert, and that's going to be it for now. That is equal to use global context. We also want to create two new use states. So let's create a new use state that's going to be player1, which is going to at the start be equal to an empty object. And we also want to get player2 and set player2, which is at the start going to be equal to an empty object as well. Then we're going to re-navigate to a page that looks like this, /battle/ and then right here, this is going to be a name of the battle. So how do we get the name? Well, we get it from params. So we can say const battle name is equal to use params. And finally, we can initialize the navigate function. Great. So now we have all of the imports. I don't think we have routed to this page yet. So let's go to index to export our battle page. We can do it just by changing the name right here and exporting it. So that's going to be battle. And now back in main, we can import the battle page. And then we can duplicate this route. Here, we can set the path to be equal to battle / and then colon battle name, which means that this parameter is going to be dynamic. And then there we can render the battle component. Great. Now we can go back and let's just style the battle component a bit better so that once we get re-navigated after joining, we can already see something on the screen. To do that, we can create a new div, and that div is going to have a class name equal to a template string of styles.flexBetween, styles.gameContainer. And in here, we have to render the current battleground. This right here is going to be a special variable that's going to say on which battleground are we currently on. So if we check our styles inside of Tailwind, you can see that we have different background images based on different battleground names. So let's go back, and for now, let's try to hard code it right here as Astral. That might work. If not, we're going to switch it later. And inside of here, right now, I want to render the battle name. So I'm going to create an H1 that's going to render the battle name. And let's give it a class name equal to text-xl and text-white. Great. Now let's save this. And I think we are ready to join the battle to test the functionality. I'm going to click join already existing battles. I'm going to click join. Let's also open up the inspect element to see what's happening. And let's join. We get a new notification, which is always a good sign. And I'm going to click approve. Joining JSM battle, that's looking good to me. And the redirect happened. We also got a notification from our event listener. So now if we go back to create event listener, we can see that this is the one that happened. New battle started. We got the arguments, which contained the battle name, the player1, and the player2, which is great. And the wallet address is there. So now we were redirected to /battle and then /JSM battle. But the screen simply seems to be white. So let's try to reload the page. And yep, nothing seems to be on there. So let's check if the battle page is properly routed. So let's see. Since we have a white background, it looks like the background wasn't applied, which is fine. But if we change the color of this text back to black, we might be able to see it. And there we go, JSM battle, which means that it's properly reading the parameters. So that's great. We have all of the data we needed so far, And we are ready to code out the looks of the Battleground page. First things first, let's focus on the Battleground background. So what we can do is we can go back to the index.js and we can create a new use state at the top. Yep, another one. So right here, we're going to create a new use state and let's call it Battleground. You can use a capital G or a lowercase g, whatever one you use, make sure to stick to that to not have any issues later on. And at the start, let's call it bg-astral. We'll have to use this prefix of bg- and then the name of the Battleground. For now, it's going to be static, but later on, we'll be able to update it using the set Battleground page. So now, let's pass the Battleground as well as the set Battleground all the way down to our context. So right here, Battleground as well as set Battleground. There we go. Perfect. Now we can go back to our battle page and we can import the Battleground. And we can simply render that string right here instead of Astral. Now, if we save that, that actually works because we put BG in front. And if you look at the Tailwind styles, if you put these background images, then you have to put the BG dash and then the name of that Battleground. So that's looking great. Now let's continue adding to our Battleground. This is looking great even on smaller screens, but if we expand it, it's looking even better. Now let's go back a bit and let's start implementing it. First, we're going to focus on extracting all important player data because we have to pass that player data all the way to the components that are going to present it. So let's create a new use effect right here. There we go. That use effect is going to happen when the contract changes, meaning when it first gets updated, when the game data changes, and when the battle name changes as well. Great. So how are we going to fetch all of the important game data? Let's create a new function called const get player info. And that's going to be equal to an async function like this. Let's not forget to immediately call it down here. So we can say if there is a contract and if there is game data dot active battle. Only if that is true, then we want to call the getPlayerInfo function. Now, inside of the getPlayerInfo, we're going to create a new try and catch block. There, we can say let player01 address is equal to null, and let player02 address is equal to null as well. That means that we're simply setting up the variables so we can use them later on once we initialize them. Now we have to check if game data dot active battle dot players 0 dot to lowercase is triple equal to wallet address dot to lowercase. If that is the case, that means that our player01 address is equal to game data dot active battle dot players 0 because we verified that right here. Active battle player 0 is equal to wallet address dot to lowercase. And this right here was supposed to be players, plural. And based on that, we also know that the player 2 address is equal to active battle dot players 1. There we go. Else, if the wallet address is not equal to the player 0, that must mean that it is equal to player 1. So we can copy these two values and we can simply change the numbers, meaning player 1 address is equal to players 1, and then player 2 address is equal to players 0. There we go. Based on these addresses, we can now fetch proper player data. First, we need to get the token, and we can do that by saying const p1 token data is equal to await contract dot get player token, and we pass in the player01 address. We can dive into our smart contract to see what the get player token function does. So if we check it right here, and find where it is initialized, we can see that it simply returns a specific player token. Then we can get the player1, const player01 is equal to await contract.getPlayer. And there we also have to pass the address of the player, and we can duplicate that, and we can repeat the process with the player02 and pass in the player02 address. Now let's dive into the smart contract to see what the getPlayer function does. So one more time, going back and searching for it, getPlayer, there we go. It simply returns a player. It is a getter function. Now, based on these variables, we can make use of them to get player health bars, mana bars, and attack and defenses. So we can say const P1 ATT as attack is equal to P1 token data dot attack strength dot to number. There we go. We can duplicate that, and then we're going to get the P1 def as defense, and that's going to be defense strength. Now we want to get P1 and P2 health and mana bars, and we can do that by saying const P1H is equal to player01 dot player health dot to number. We can duplicate that 3 more times. The second one is going to be P1 mana, so we can simply change the player health to player mana. We're going to have player 2 health and then player 2 mana. Player 2 health is going to be like this. We have to change the number, player 2, and we have to change the player mana right here. Again, make sure that you have it exactly like this. P1 attack, P1 token data, attack strength, P1 def, P1 token data, defense strength, and then P1 health is player 1 health, P1 mana, player 1 mana, P2 health is player 2 health, and then P2 mana is player 2 mana. Great. Now that we have those values, we can set them to the state. So we can say set player 1 is ... We want to spread all the values of the player 01. We want to set the ATT to be equal to P1 ATT as in attack. Def is going to be P1 def. Health is going to be set to P1H. And mana is going to be set to P1M. We can duplicate this, set the player 2, spread the player 02, set the attack to be equal to X, just a string of X, and def equal to a string of X, because we don't know the opposing player's attack and defense strengths, but we do know their health and mana, so we can set P2 health and P2 mana. Great. And finally, for the error, for now, we can simply console.log it. Great. So now we're getting all of the player data, and we're setting it to player 1 and 2 states. It also looks like I have a typo right here, address with a single D. So this has to be the same as these variables right here to make sure it works. Great. Now we can make use of these player data variables. So let's scroll down and let's create a lot of different reusable functions so we can create the layout of our game. First, let's show the alert at the top of the battle page the same as we did with the page higher order component. So we can go here and we can copy this alert prompt, because the higher order component is used in all the home pages, but it's not used in the battle, so we have to paste it here as well. So show alert .status and alert show alert type and show alert message. Great. Now we can show a custom player info component. So right here, let's create a player info component. And to that component, we're going to pass a player, which is going to be equal to player 2, because we're showing them at the top first. We are on the bottom page of the screen. And we also want to show the icon. So player icon is equal to player 02 icon. And we can also pass empty as margin top. Now, of course, if we save, that's not going to work because this component doesn't yet exist. So in this file, we're going to use a couple of components we're going to create. A player info component, a card component, an action button, and also the game info. So what do you say that now we go to the components folder and create a basic structure for all of these components we'll be using? So let's start from the action button. That's going to be action button.jsx, and we can create an RAFCE inside of there. Then we're going to also create a card component. So card.jsx, and we can also run RAFCE. Finally, we're going to use the game info component .jsx, and we can run RAFCE. And finally, the one we already called is the player info component .jsx, and we can also run RAFCE. Now we can go to index and we can export all of these components. So we're going to have the action button. Then we're going to have a card component. Then we're going to have a game info component. And finally, we're going to have a player info component. There we go. So now we can export all 4 of these right here. And we, of course, need to add the commas. There we go. Finally, going back to that's going to be battle page, we can now import all of these components at the top. So let's import alongside the alert. That's going to be action button, card, game info, and player info components. Great. Now we can continue creating the basic layout, keeping in mind that all of the components are going to be here. So below our player info, we're going to have a div, and that div is going to have a class name equal to, inside of curly braces, styles.flexCenter, and also flex-call and my-10. Inside of that div, we want to show a card component. So right here, we can render a self-closing card component. That component is going to have a couple of props, such as card is equal to player2, title is equal to player2 (player name), not the action button here. We're also going to give it a player2 variable to know to differentiate different cards. And then we have to provide a card ref, which is going to be equal to a ref that we're going to create later on. For now, let's simply leave this as an empty string. Now, below that card, we're going to create one more div. And that div is going to have a class name equal to flex, items-center, and flex-row. Inside of there, we want to render the action button. So this is going to be the action button to attack a player. So it is a self-closing component that's going to have an image URL equal to attack. It's going to have a handle click equal to. For now, we're going to leave this as an empty callback function, and we're going to implement the functionality later on. And we can add rest styles equal to mr-2 for margin right, hover, border-yellow-400. Great. Now we can copy the card one more time below the action button. This is going to be the card for player 1. So we can say card is player 1, title is player 1.player name, and right here we don't need to provide any player 2 variable, but we can provide the rest styles equal to mt-3 to divide it from the top card. And finally, we can copy the action button and place it below the card, because this time this is going to be a defense action button. Instead of margin right 2, we're going to have a margin left 6, and the hover is going to be border-red-600 for defense. Finally, below this div and below one more div, we want to show the player info for the other player. Remember, we have already created it for the one at the top, but we can now copy this, paste it here, and that's going to be player 1 as well as player 01 icon. And below that, we want to show the game info component, just a simple self-closing component. Now, if we save this, you can see that the text is here. It's barely visible, but all parts are here. The player info at the top, the opposing player's cards, Then we have our own card, as well as the action buttons next to that card. Then we have our own player info. And finally, we have the game info. So everything is looking great to me. But now is the time that we jump into all of these components individually and we create their look and feel. So let's go ahead and let's get started from top to bottom. The first one on our list is going to be the player info component. This one is going to be interesting because we're going to have different colors on the health bars depending on how much health does a player have. So it's definitely an interesting functionality to think about how to implement, but I'm going to show you how to do it in this video. So let's start by importing React Tooltip coming from React-Tooltip. Then we can also import the styles coming from /styles. Then we can set a constant variable, const health points. This is going to be a number of health points, which is going to be a total of 25. Then we know that we're passing three different things into the player info component. We're passing a player icon, and finally a MT or margin top property. Now, based on that, let's render the look and feel of it. We can first have a div, and that div will have a class name equal to styles.flexCenter. And then only if there is margin top, then we want to add MT4. Otherwise, we're going to add MB4 like this. Great. So for the first card, we want to push it away from the top. And for the second one, we want to push it away from the bottom. Then inside of there, we're going to have an image tag. This image is going to have a source equal to player icon. And it's going to have an alt tag equal to player2. Finally, we can give it a class name equal to w-14 for width, h-14 for height, object-contain, and rounded-full to make it into a circle. If we save that, we can now see that we get an opponent right here on the top, and we get the blue one on the bottom. We can also add a data-4 property right here, and that's going to be equal to player dash. If we are empty, that means that it is player 1, and then otherwise it's going to be player 2. And we can also give it a data-tip property. This will allow us to know which image is this player representing. Great. Now below that image, we're going to have a div, and that div is going to have another data-4 property, and this is going to be for health. And one more time, we're going to copy what we had above. So that's going to be dash, and then if it's empty, then it's going to be 1. Otherwise, it's going to be 2. So we're going to paste that right here. And then the data-tip is going to be equal to health, and then player.health, like this. Finally, let's give it a class name equal to styles.playerHealth. And there we go. There is the bar where the health will go. But now is our time to actually put the health bars inside of this health div. So to do that, we'll have to find a way to represent the number 25 as specific bars. To do that, we're going to open a dynamic block of code. We're going to make an array, and then we're going to spread the array of player.health. Then we're going to take the keys out of that property, and we want to map over that. We're going to map over each individual item, and we're going to also get the index. Now we want to return something for each property, and we're going to return a div. That div is going to have a key, which is going to be equal to, let's do player-item-, and then we can render the item right here. And let's give it a class name. In this case, that's going to be styles.playerHealthBar. If we save this, nothing is going to happen yet. That's because we have to calculate the health level. We have to know, is it green, is it red, or is it orange? To do that, we can create a new function at the top, const health level. It's going to take in the health points, and then based on that, we can check inside of parentheses if points is larger than or equal to 12. In that case, we can render the bg-green-500 color. Then we're going to have an else, and we want to check if points is greater than or equal to 6. Then we want to render the bg-orange-500. And else we want to render the bg-red-500. And now we can put that health bar here. That's going to be health level, and we're going to pass in the player.health. If we save that, you can see all of the health bars right there. But you can see they're kind of close together, right? We have to divide them somehow. But how are we going to know how many there are? If we put a too large of a margin, something like margin right, let's do 2, then they're going to spread too thin. But if there isn't a lot of them, then we have to increase the width or lower the margin. So we're going to create another function to calculate that as well. Const margin indexing is going to be equal to a function that's going to accept an index as the parameter. And then we're going to check if index is not equal to health points minus 1, then we're going to return mr-1, else we're going to return mr-0. And now we can pass that margin indexing right here as a function and pass the index as well. Once we call this, this is going to look much better. Perfect. I like this. Now we have to do a similar thing for the mana, but we're just going to have a circle that's going to say the number of the mana that we have. So what we can do is we can now close this div, as that is a self-closing div. So I'm just going to close it right here. And then below this block of code and below the div that's wrapping it, we can create a new div. And this div is going to be for the mana, and it's also going to have a data4 property. The reason why we're adding this is because the React tooltip package is going to use it later on. So once we hover over it, we'll be able to get more information. So data4 mana dash, if it's empty, then it's 1, otherwise it's 2. We can say data dash tip, it's going to say simply mana. And the class name is going to be a template string of styles.flexCenter, styles.glassEffect, and styles.playerMana. Inside of there, we can render a dynamic string of player.mana or 0. Now, if we save that, you can see game is slowly starting to make sense, because we can see that both players have full health as the game just started, 25 health, and they both have 10 mana, which is exactly as it should be. That is great. Finally, let's add the tooltips to make even more sense of the game data. First, we're going to add a React tooltip component, and this one needs to have an ID. So the ID is going to be equal to a template string of player dash, and we're going to do the same thing one more time. If it's empty, then we're going to say 1, else it's going to be 2. It's going to also have an effect, which is going to be set to solid. And it's going to have a background color, which we can set to something like hash 7f46f0. I found this color to work really good. And inside of there, we can render 2 different p tags. The first p tag is going to render the name of the player. So we can render a span inside of there. And that span is going to render the name, or rather it's going to say name right here. And after the span, we can render the player (player name). Now, the p tag is going to have a class name equal to styles.playerInfo, and the span is going to have a class name equal to styles.playerInfoSpan. Great. Now we can duplicate this p tag below, and the second time we want to render the address of the player. So in here we can say player.playerAddress question mark dot slice from 0 to 10, only first 10 characters. Now let's save this. We get an error because we are missing a dot right here. But if we save that, we get an error again. So let's open up the inspect element. Let's go to console. It looks like that slice is undefined because the player info is typed wrong here. That shouldn't have been here at all. Sometimes autocorrect messes things up. But check this out. If you now hover over the player, you can see name account 2, name account 2, which doesn't seem to be right now. We'll have to fix that. And then also we can see the address of that account, which is great. I'm now wondering why the account is the same for both, or at least the name, and the address also seems to be the same for both. So if you go back to battle, that's player info, the first one should be player 2 and the second one should be player 1, which seems to be good right here. But then if we go above, let's check where we're setting them. Set player 1, set player 2. That's looking good to me. We spread the player 1. We spread the player 2. Attack, defense, health. It's all looking good. That's interesting. Player 1, player 2. Yep, that's looking good to me. And in here, the error could be in here. If active players 0 is the wallet address, then we know that the 0 player is the player 1, and then we know that the player 2 is the second index. Else, player 1 is the second player, and player 2 is index 0. This is looking good to me as well. So right now, I cannot seem to find an issue with this, so we're going to definitely revisit this later on if the issue persists. But now we can go back and we can also add the tooltips for the health and for the mana. So let's create another React tooltip. This one is going to be self-closing. We're going to give it an ID equal to a string of health dash empty, in that case 1. And then in here, we're going to have 2. Let's give it an effect of solid. And let's give it a background color the same as we did before, so we can copy it right from here. That's for the health. So if you hover over the health bar now, you can see health 25, which is great. It's much easier than reading all the lines individually. And we can duplicate that, say mana right here, and save it. And now it's going to say that this is mana. This is a beautiful way to add interactivity to your application. You can see it was so easy to add these tooltips, but they help so much. So this is looking great to me right now. We just gave much more sense to the game, since now we have the icons, we have the health bars, and the mana bars. Now is the time that we implement the next step of the battle page, which in this case is going to be the cards themselves, the main star of the show. So let's jump into the card and let's get started. To start implementing our card component, we can import something known as tilt from React / parallax - tilt. You're going to quickly see what this package does. It's quite cool. And then we can import these styles coming from / styles. We can also import something known as all cards coming from / assets. This is an array of all card assets that we have prepared. Now, what we want to do is fetch a random card asset from the collection. So let's create a function, generate random card image. That's going to be a function. There, we can tap into all cards, access the math.floor, and then math.random, and then we can multiply that by all cards .length -1. This function right here is going to help us generate a random card. Once we do that, we can say const img1 is equal to generate random card image, and also we can do the same thing for image 2. That way, we're making sure that every player has a unique card. Now, our function does accept some parameters, things like card, title, card ref, and player 2. So let's get them right here. Card, title, rest styles, card ref, and player 2. Inside of here, let's create a div that's going to have a reference to this card, and reference is going to be card ref. If we save this, it might break the application, as I thought. If we put it as an empty string, it's still gonna break because it's not allowing us to pass faulty references. So for now, let's remove that part. We're gonna bring it back in later when we will need to add those explosion animations. For now, let's add a class name equal to a template string of styles.card container and also rest styles. Now, inside of there, we want to render the image. This image is going to have a source equal to player 2. If it is a player 2, then it's going to be image 2, else it's going to be image 1. It's going to have an alt equal to card, and it's going to have a class name equal to styles.cardImg. Once we save this, you can see one card. The second one seems to be broken though. So something doesn't seem to be right. In this case, I think I forgot to add a parenthesis to wrap the all cards.length -1, because what it was doing so far, it was multiplying the math.random times all cards.length and then decrementing 1. We want to do this together and then multiply it. Once we do that, we can see 2 great cards. And every time that you save a file, you're gonna get 2 new ones, which is phenomenal. The game is already looking so much better. Now, you can see that the attack and defense values are currently empty. So now we have to add them. And you can also see that the action buttons are not currently used. So soon enough, we're going to implement those as well, but that's in a separate component. For now, let's focus on attack and defense values. Below our image, let's create a div. And that div is going to have a class name equal to a template string of styles.cardPoint container. On small devices, it's going to have a left property of 21.2%. I found this value as it's very specific, but to work the best. And then the left is going to be 22% right here. And finally, we can give it a styles.flexCenter. Inside of that div, we want to render a p tag. This p tag is going to have a class name equal to a template string again of styles.cardPoint and text-yellow-400. And it can render a dynamic property of card.att. If we save that, you can see a number 9 here and X right there. If we mess with the percentages a bit, like let's do 10, you can notice it is a bit off. But with those values, we're ensuring that it's always going to be right in the middle. With that said, we can now duplicate this div below. In here, what we have to change are the percentages. So let's do 14.2 here. For the left, in this case, it's not going to be left, it's going to be right. And let's do something like 15%. And we're going to change the color to text-red-700. And there we go. The opposing players' values are hidden right here. And then in here, we have 9 and 9. And now we know our attack and defense values, which don't seem to be right yet, but we're hopefully going to fix that soon. Finally, we need the title of our player. So below this div, we can create one more div. That div is going to have a class name equal to a template string of styles.cardTextContainer and styles.flexCenter. Inside of there, we can render a p tag, and that p tag is going to render the title. If we save that, we can see account 2 and JS Mastery. Oh, interesting. So it is picking up JS Mastery right here. That's good. And then we want to give that a class name equal to styles.cardText. If we save that, this is looking phenomenal. If we expand our browser, our game is looking much more like a game now. This is such a beautiful battleground. We have our images, but most importantly, our data is right here. Although these percentages don't seem to be right now, we'll have to look into that as that number moved off. So in here, I think that is small left and left, but on the card 2, it's going to be small right and then right here as well. Now, if we expand it, yep, this is so much better. The values are still there. Beautiful, beautiful. We have the account 2, health, attack points, names of the players. This is looking great. With that said, we are done with the card component and we are ready to move to our action button component, which is right here. The opposing player is not going to have action buttons because we cannot make moves for them, but our card will have action buttons, 2 of them, one for attack and one for defense. So let's dive right into the action button component and let's start implementing it. It's going to be quite simple. We're going to import the styles from /styles. We're going to accept all the props that we passed into it, such as img URL, handle click, and rest styles. We're going to render a div that's going to have a class name equal to styles.gameMoveBox. Also, styles.flexCenter. Also, styles.glassEffect, and finally, rest styles. If we save this, we get 2 beautiful circles. Finally, inside of there, let's render the icons. So we can say image, source, img URL. And for now, they're huge. But if we add the alt tag, such as action img, and we add the class name equal to styles.gameMoveIcon. If we save that, this is looking so much better. You can see how simple it was to implement the look and feel of these buttons. Oh, but there's one more thing that we missed right inside of our card component. I promised you we're going to look into how this tilt functionality works. Trust me, it is quite straightforward. This package allows you to tilt different divs immediately. The only thing you have to do is wrap your div with a tilt component. So let's call it tilt. Let's properly close it at the end of the component, indent it properly, and save the file. Take a look at this. I take my cursor and I tilt over the card. Isn't that cool? Never try to reinvent the wheel. If there are cool packages that do this, just try to utilize them. That's one more tip I can give you. So yeah, this is already looking so much better. Let's expand that. There we go. This is a beautiful game. All in the browser, Web3 and blockchain connected. Great. Now let's go back and let's implement the game info component. So we can go to battle and we can control click to go into the game info. This is going to be a special component that's going to let the user know the rules of the game. So it's going to be a modal that's going to come up from the right side, and there we'll be able to see the rules, we'll be able to exit the battle, and we'll be able to change the battleground. So quite a lot of interesting things. So that's going to be our next task. You can think of the game info component as the menu of our application. We don't have a classic navigation bar here, as this is not a classic web application. This is a game, and games have menus. So in here, you'll be able to quit the game, you'll be able to change the battleground, you'll be able to traverse the game more easily. So let's get started. First, we're going to import React as well as the use state coming from React. Then we're going to import that same old use navigate coming from React Router DOM. We're going to also import the custom button component that we have already created from /custom button. We're going to also import our old trusted use global context coming from /context. Let's also import some assets such as alert icon and game rules coming from /assets. And finally, let's import the styles coming from /styles. styles. In here, we can first fetch some values from the context. So let's say contract. Let's get the game data as well. And let's get the set show alert. That's equal to use global context. Then in here, we're going to have a state that's going to trigger our sidebar. So we can say toggle sidebar and set toggle sidebar at the start set to false. And finally, we can initialize our navigate function by saying const navigate is equal to use navigate. Later on, we're going to have a function to exit the battle. So let's create it. Const handle battle exit is going to be equal to an async function, which for now we can simply leave as an empty block. Great. Now we can start with the JSX side of things. We're going to have an empty React fragment to start with. And then inside of there, we're going to have a div. This div is going to have a class name equal to styles.gameinfo_icon_box. Inside of there, we're going to have another div, and this div is going to have a class name equal to a template string of styles.gameinfo_icon and styles.flexCenter. Once we click that, so on click, we want to have a callback function where we set toggle sidebar to be equal to true. We want to turn it on. And there we can render an image. That self-closing image tag is going to have a source equal to alert icon, an alt tag equal to info, and a class name equal to styles.gameinfo_icon_image. Let's save it. And there we go. On the right side, you can see this icon. When you click it, it should open up a menu. So now we can go 2 divs down and we can code that menu out. To do that, we can create a div and we can give it a class name. That's going to be equal to a template string of styles.gameinfo_sidebar. And if the toggle sidebar is true, then we want to have a translate -x-0. Else, we want to have a translate -x-full, like this. We also want to give it a styles.glass effect and also styles.flex between. Finally, we want to give it a backdrop -blur -3xl. Now, if we save this, and if you have clicked that icon, you should see something that looks like this, a sidebar. But let's give it some more depth. Inside of this div, we're going to create one more div. That div is going to have a class name equal to flex and flex-call. Inside of that div, we're going to have one more div, and that div is going to have a class name equal to styles.gameinfo_sidebar_close-box. Inside of there, we can create a new div. That div is going to have a class name equal to a template string of styles.flexCenter, as well as styles.gameinfo_sidebar_close. And there we can simply render the character X to close it. There we go. You can see the X at the top right. And let's give it a non-click. And that's going to simply set the set toggle sidebar to false. So immediately we can open it and we can close it and it nicely animates in. This is great. Now below that, below this div and below one more div, we want to create an h3 property. It's going to have a class name equal to styles.gameinfo_heading. And there we want to say game rules, like this. This is already looking better. Below that h3, we're going to have a div, and that div is going to have a class name equal to empty-3, like this. Inside of there, we can loop over our game rules. So we can say game rules If we save that, you can see they're gonna appear right here. And those rules are coming from assets. So if you click them right here, you can see it's simply an array of different strings that showcase the rules. So let's map through them. .map. We're gonna get a specific rule and an index. And for each rule, we want to return a p tag. That p tag is going to have a key equal to a template string of game dash rule dash index. And we can give it a class name equal to styles.gameinfo text. Inside of there, we can render a span element that's going to have a class name equal to font-bold, and it can render the index +1. Then outside of span, we can put a dot and we can render the rule. If we save this, it's looking so much better. As you can see, we have those bolded rule numbers, and then we have the actual rules. So this is now a beautiful menu with the rules. But let's add a couple more buttons. So we're going to go outside of this div and outside of one more div to create a new div. This div is going to have a class name. It's going to be a template string of styles.flexBetween. It's going to have a margin top of 10, gap of 4, and w-full. Inside of there, we want to render our custom button. That button is going to have a title equal to change Battleground. And it's also going to have a handle click that's going to have a callback function with a navigate that's going to go to /Battleground. And we can replicate that button below, have the title be equal to exit battle, and the handle click is going to call the function we created above. So this function is going to be handle battle exit. Great. This is our menu. We can now collapse it. We can reopen it. Of course, on mobile devices, it goes over the entire screen. But if we expand this and now try to open it, you can see it is even better because it doesn't hide the game. It just appears on the right side. Later on, we'll be able to exit the battle and change the battleground straight from here. Now that we're done with the UI and the UX of our battleground, implementing the change battleground functionality might seem like the next reasonable and a fun step. So let's do the change battleground next. I'm going to collapse this, close the rules, and we can create that new battleground page. So let's go to main. We can duplicate one of the routes, and we can name it Battleground. Of course, we have to render the Battleground component or the Battleground page. So let's render it right here, and let's import it from pages. Of course, we have yet to create it. So let's go to page, and let's create a new battleground.jsx page. Inside of there for now, we can run rafce, and let's not forget to export it. So here we can say import battleground from battleground, and we can export it at the bottom. Great. Now, if we click the menu and we click change battleground, you can see it opens up a new page. So now is our time to close all of the currently active files, to clean our workspace a bit, and then just open up the new and clean Battleground page. Let's start implementing it. Let's make our game even more fun by allowing users to choose their own battleground. Inside of our battleground, we're going to import the use navigate hook coming from react-router-dom. We're going to also import the styles coming from /styles. Finally, we can import the alert coming from /components, since this is yet another page on we haven't yet imported the alert component. We're going to import the battlegrounds coming from /assets. And if we look into this, this is simply an array of objects with the ID, the image, and the name of the battleground. Finally, we can import the use global context. And that's going to be coming from /context. Inside of here, we can say const navigate is equal to use navigate. And then above that, we can get all of our variables from context. So we can say const, and let's try to get the set show alert and also show alert. And that's going to be equal to use global context. There we go. This is perfect. But now we also have to have a state to know which battleground is currently turned on. So if we look into the use global context, we have already created that variable. So we're going to go back and we're going to import the set battleground as well. Great. Now we can start coding out the layout of the website. So that's going to be class name equal to, inside of a template string, styles.flex center. Also, styles.battleground container. This is immediately going to change the background. We can also copy the alert status coming from page HOC. Remember, the same alert we copied already, and paste it here. This is going to allow us to show alerts when they need to show. And we're going to have an H1 just below it. This H1 is going to have a class name equal to a template string of styles.headText and also a string of text-center. Inside of there, we can space it out in a couple of lines. We can say choose your. In a new line, we can put a span that's going to say space, battle space, and then below that, we can say ground. Choose your battleground. But to this span, we can give a class name equal to text-site violet. That's going to make it this great purplish color. Below that H1, we can create a div element. And this div is going to have a class name equal to a template string of styles.flexCenter, styles.battlegrounds wrapper, with a G being uppercase like this, battlegrounds wrapper. Now it looks like I misspelled styles, so let's fix that. And inside of here, we're gonna map over all of our battlegrounds. By saying battlegrounds.map, we're gonna get a specific ground, and we want to return something for each ground. That something is going to be a div that's going to have a key equal to ground.id. It's going to have a class name equal to a template string of styles.flexCenter and also styles.battleground card like this. And it's also going to have an onClick property. And there we want to have a callback function where we're going to handle the battleground choice. And we're going to pass in the ground. So now we can create a function right here, const handle battleground choice, and that's going to be equal to a function like this. And the function is going to accept the ground as the first and only parameter. Finally, inside of that div, we want to render a self-closing image tag. That image is going to have a source of ground.image. It's going to have an alt equal to ground, and it's going to have a class name equal to styles.battleground card img, like this. And always make sure the ground is capitalized, battleground. If we save that, we can see 4 different images. Below the image, let's also create a div, and this div is going to have a class name equal to info and absolute. Inside of there, we can render a p tag that's going to say ground.name. And we can also give it a class name equal to styles.battleground card text, and save. Now we cannot see it yet, but if you hover over these battlegrounds, you can see it nicely right here. Although the mobile view is not the best one to check the full power of our battlegrounds, so let's expand our view to the full desktop. Would you look at that? This is looking so much better. We can see all 4 battlegrounds right here. But I think something is wrong with the layout, as we should be good on tablet and mobile devices as well. This right now is not looking that good. So let's see if we missed a property somewhere. That's most likely going to be this div or the wrapper div. So the wrapper div should be flex center and also battlegrounds wrapper. In here, I miss an L. So if I add an L right here, you can see that this is now so much better. And we can also expand it. And you can see how immediately it goes into 2 rows and 2 columns. This is looking beautiful. Now, of course, we didn't yet implement the functionality to actually choose a battleground, but that's going to be our next step. So we can collapse this and we can implement the handle battleground. In here, it was supposed to say choice. So let's fix that, fix it here as well. And now we can implement the logic for this function. Inside of here, we want to first set the state. So that's going to be set battleground is going to be ground.id. Then we also want to set it to the local storage, because if a user reloads the page, we need to keep track of the battleground they chose. So that's going to be set item battleground, and that's going to be equal to ground.id. Finally, we're going to use the set show alert. Status is going to be true. Type is going to be info. And finally, we can say a message of something like a template string. Ground.name is battle ready, like this. And finally, and most importantly, we can call the set timeout, which means that it's going to happen in 1 second. That's going to be just enough time for us to look at the alert. And there we can navigate. So we can say navigate, and we can pass a -1 parameter. This is going to navigate us back from where we came from. In case we came from a battle page, this is going to navigate us back. And that's going to be it for the battleground selection page. Let's choose this battleground right here. Simon is battle ready, and we are back on our beautiful battleground page, but now with a completely different background. Now we can go back to our menu, we can go back to our change battleground, and let's do something like this one. And there we go. This is looking beautiful. Now we're going to keep focusing on improving the gameplay functionality. We're actually going to make the game work, and we're going to do final checks to make sure that the user is actually logged in, that the user has enough funds and is connected to the right network. We have to ensure all of these steps are done to be able to battle with the other player. Great. Slowly but steadily, we're making phenomenal progress. Great job on coming this far into this video. Now, if we reload the page, you're going to notice that the battleground changes. So let's go to the index.js of our context. And right here at the top, where we're initially setting the battleground, we also have to make sure to check the local storage. We can do that by adding a new use effect right here. That use effect is only going to happen at the start. There, we can say const is battleground, meaning is it saved in local storage. That's going to be equal to local storage.getItem battleground. And then we can say if is battleground, then we can simply set the battleground to be equal to is battleground. A more proper name for this variable would be battleground from local storage. Great. And else, if we don't have the battleground, then we want to say local storage.setItem battleground, and we're going to set it to the current one, which is essentially the base battleground. Great. Now, of course, I have to rename this in the if as well. And if we reload and change the battleground to something like this one, there we go. We have this beautiful blue battleground, and I can reload the page, and it persists. This is exactly what we wanted to achieve. But now let's focus on ensuring that the player can make proper moves in a battle and also that they can join the battle and create a player. To be able to do all of those things, a player needs to be on the Avalanche Fuji test network, and they have to have enough AVAX. So let's create a modal that's going to ensure that that happens. We can do that by going back to main. Inside of here, we're going to import a component that I already provided to you at the start. That's going to be import onboard modal coming from /components. And now let's go to our components folder. Here is our onboard modal. Again, don't really worry about the code. This is doing some simple checks like making sure that we have Core Wallet installed, that we have a wallet connected, that we are on the right network, and that we have enough AVAX. So let's export it from the index right here. We can export, or rather import in here, the onboard modal, and we can export it right here, onboard modal. There we go. Now inside of main, we can put it above all routes because it should always be existent. And it's going to be a simple onboard modal self-closing component. There we go. And in most cases, we should not even be able to see it, as you can see right now. But if we change the network on this account by going to see all networks and then switch to Bitcoin testnet, we can go back and reload the page. Now we should be able to see that modal, but nothing happens. The reason why nothing happens is because we're already on the battle page, and we shouldn't even gotten this far if we were on the wrong testnet. So what we can do is we can switch back on the account 2 to the right C-chain testnet, reload the page. Okay, that's great. And we can try by creating a new account. So let's add an account. That's going to be account 3. Sometimes Core opens a lot of these notifications, so we have to close them one by one. And we have to click approve. There we go. Now on the account 3, we can re-navigate to the just / URL. And now if we approve our account 3 connection, we can close other windows. You can see that the modal actually appears. It says, oops, you don't have enough AVAX tokens in your account. So if more than 24 hours have passed since you last time pulled it, then you can try and fetch some new tokens for the account 3. In my case, more than 24 hours have passed, so I'm gonna paste the address and request some AVAX. Now, as soon as AVAX arrives, you should be able to see it here. There we go. And if I reload the page, the modal disappears, which is great. Again, just one extra failsafe to make sure that we are ready to use all of the application functionalities. Now, to make the modal fully work, we have to go back to the index of the context, and we have to add one more use effect below this one. This use effect is going to reset Web3 onboarding modal params. So right here, let's say use effect. There we go. It's going to only happen at the start once we open up the application, but it's going to have a couple of different listeners. So let's create a function called reset params. It's going to be an asynchronous function. And in here, let's say params, and let's spell it properly. There, we want to get the current step of the modal. So const current step. And let's await get params, which is a function. And this function is coming from the utils of the onboard. So make sure to put import get params utils onboard. And again, don't really worry about this. This is mostly to make sure that the user can properly play the game. Finally, once we get the current step, we can create a new use state. So right here, let's say use state. That's going to be step, set step, and at the start, it's going to be set to 1. Now we can simply say set step is going to be current step dot step. And we can now call this function immediately after the page loads. So that's going to be reset params. And we can also say window ? Dot Ethereum. So we're accessing that Ethereum object, question mark dot on chain changed. So on chain changed, we want to call the reset params function like so. And let's put a comma here. We can duplicate this. And also when the accounts change, so we can say accounts changed, then we also want to call reset params. So this is going to ensure that once we get funded or once we change the accounts, this function is reran and the modal is going to disappear. Now, in case that the step is set at -1, that means that we are not ready for the game, then we cannot call our function to create event listeners. So right here, we're going to check for contract, but we're going to also check if step is not triple equal to -1, like this. There we go. Let's put the minus right there. There we go. This is looking good. And therefore, we can also add a step as the parameter right here. Great. With that said, we are now on our third account, but we haven't yet really played the game between first two characters. So let's jump into JS Mastery account. Let's close all of these extra notifications that appeared. Reload the page. It looks like I have to approve it again. And it looks like it wants me to create a battle again. But if I'm not mistaken, I have already created a battle on this account. So in this case, we should already be redirected to the active battle that JS Mastery is in. So let's head straight to a page called Create Battle, and let's make sure that our use effect checking for the game data is working. Right here, we have access to the game data object. So what we can do is say, on top of this, if game data question mark dot active battle question mark dot battle status is triple equal to 1. In that case, we want to navigate to a template string of /battle/ and then game data dot active battle and then dot name. And we can put this under else if. There we go. So let's reload the page. And as soon as we do that, you can see that we are redirected to the battle page. Now, if we try to go back manually to the home page, you can see the home page redirects us to the create battle page, and then create battle page redirects us straight to the game. So now the user cannot jump out again unless they use the exit functionality, which we didn't yet fully implement. So now we are in a game and we have the UI and the UX completed. But what about the functionality? How will these player battle? Well, let's jump into the battle page. And first, let's check out the attack and defense values. I think we have some problems there, as the sum of the attack and defense should always be equal to 10. In this case, they add up to 6, which doesn't seem to be right. So if we scroll up, let's check this out. We have our player 1, and in here, under attack, we're passing player 1 attack, which is equal to P1 token data dot attack strength. And under def, we're passing P1 def, which is equal to token data dot defense strength. This is looking good. So let's try to console log it. Let's try to console log P1 token data. Let's see what do we get back from that. I'm gonna inspect, go to console, and reload the page. Now, it looks like we have some warnings, which we can fix later, but in here, we do get back the player. It looks like the player's name is JavaScript Mastery, the ID is here, and here are the attack strength and defense strength values. They are all of a type, big number, which is why we have to use the .toNumber functionality. But still, right in here, we can already see that they are different. This is 0x03, and this one is 0x07. So I'm not quite sure why are we getting different values here. So let's try to dive deeper into it. Let's try to console log specifically this number. And then below that, let's console log that number, .toNumber. So we should be able to see what the value is. And there we go. We can see it. It is 3, which is good. Now let's repeat the procedure with the defense strength, and save. And it looks like it is 7. So where did I make the mistake? Def, p1 def. This is all looking good, but the value right here is 3. Oh, that's easy. If the values here are correct in the state, then it must mean that we incorrectly set them right here in the card. So let's dive into the card. And right here, we have car.attack and car.attack here. Here, we were supposed to have def. So now the values are also correct, 3 and 7. Perfect. Finally, we are ready to start implementing the attack and defense functionalities, which we should implement right here in the handle click. To start doing that, both of these are going to call one function. The function is going to be called make a move, like this. And we're going to pass different parameters to each one. The attack function is going to say make a move 1, and then the defense function is going to say make a move 2. Based on that, we're going to know what the user wants to do. So now, below our use effects and above our return, we can create a new function, const make a move. And that's going to be an asynchronous function that is going to accept the choice as a parameter. Choice, of course, being a number between 1 and 2. Now, immediately, to make things a bit fun, let's call the special play audio function. And inside of there, if the choice is triple equal to 1, then, as we already discussed, we want to play the attack sound. Else, we want to play a defense sound. So now if we save this, let's try clicking on attack. And if I do that, nothing happens. Let's see. In here, we're passing it, but are we using the handle click in the action button? It looks like we're not using it yet. Right here, we have to pass the onClick property equal to handle click. Now that's going to execute the right function. If the number is 1, then we want to hear attack sound, else we want to hear a defense sound. Let's test it out. There we go. I heard them on my end, and if you have your speakers turned on, which I'm guessing you do because you're listening to me, then you should have heard the attack and defense sounds as well. Beautiful. That is great, but of course, the sounds themselves won't actually do anything. So now our next job is to tap into the smart contracts functionality and actually make the move. Let's do that right away. To call our smart contract function, let's open up a new try and catch block. Inside of try, we're gonna await contract dot attack or defend choice. And this is a function that we have to call from the smart contract. So let's move to the Web3 side of things, dive into contracts, AVAX gods, and let's search for attack or defend choice. A function on line 277. User chooses attack or defense move for battle card. This function accepts a couple of parameters. It accepts a number, which is a choice, 1 for attack and 2 for defense. And also it accepts a battle name, so we know in which battle are we making the move in. The first thing that happens in the function is we get the instance of that specific battle by the battle name by calling the getBattle function. Then we have a couple of checks. First of all, we need to require that a battle has started. In this case, it is. Then we have to require that the battle has not yet ended, which in this case, it has not. Then we have to require that a player is in the battle. In this case, we are. And then also, this must be our first move. Meaning, if we played and the opponent didn't yet play, then we have to wait. We have already made our move, so we have to wait a bit until the opponent plays. Then we're going to register a player move by passing 0 or 1. We're going to get the battle. We're going to set the variable moves left to be equal to 0 or 1. And then we're going to emit the battle move action, which is the most important thing right here. As you know, when we emit an event, we can listen for it on the front end. And finally, if there are no moves left, we're going to call an internal await battle results function. This function is only going to happen if both players have made their move. And if that is the case, then we can dive into this functionality right here. we are again going to get the battle, and then we have to check that only players in this battle can make a move, and we have to check that the players have properly made their moves, both of them. And then we can call the resolve battle function. This is where the game logic actually happens. We have to look into all of the attack values, health values, defense values, and so much more, and then finally determine the outcome of the battle. But that's going to happen once both players have made their moves. And we're going to come to this later on once we finalize the make a move functionality first. So now that we know how the attack or defend choice functionality works, let's finalize that. And then later on, once both players make their moves, we're going to explore the resolve battle functionality in more depth. Great. So we're going to pass in a choice, and we're going to also pass a battle name. Finally, we're going to set the alert, set show alert to be equal to status of true, type of info, and message of a template string, initiating, and then if choice is triple equal to 1, then we can say attack, and then else we're going to say defense. Great. Finally, for the error, for now, until we implement better error handling, we're simply going to console log the error. Great. Now again, let's not make the same mistake we did before, and that is to finalize the functionality without adding event listeners. So now we can move into our create event listeners function, and we can add an event listener for make a move. So right here below this add new event, we can create a new filter for moves. So we can say const battle move event filter. And that's going to be equal to contract.filters.battle move. We can again copy the add new event, paste it below. And in this case, we won't really do anything here. We just want to console log it. We want to know that the move has been made. So let's console log battle move initiated. And we can pass in the arguments. Great. So now let's open up the console. Let's fix those warnings with the game rule index. I'm going to search for that, and that's going to be in the game info. It looks like I forgot to put the $sign and curly braces to have different keys. If I fix that and reload the page, there we go, that error is gone. So now let's put this down and let's try to make a move. In this case, I'm going to make an attack move. So I'm going to click attack right here. We get that great sound, but this time we also get a new notification. Let's click approve. This does take some time. There we go. We have initiating attack on top from the alert. And then we should be able to see this event listener. But it looks like I've made a mistake. I forgot to replace the event right here. So battle move event filter. So that's why we're not going to see a console log, but this is definitely working. Because now if we try to do that again, we get an error inside of the console. The error is going to say something like, you have already made your move. And this is not really easy for users to see, right? It's in the console and we have to visually display that something went wrong. So to do that, we're going to implement custom error handling. In this case, it's really hard to pull the data from here because it has the data, it has the message, execution reverted, and so on. It doesn't have a clear error message. You can see it is all inside of this huge string right here. So what we can do is we can strip out this first part, and then we can only keep the second part as the error message. To do that, we're going to use regular expressions. So let's go to our index page of the context, of course, and below our show alert use effect, we can create a new use effect. This use effect is going to be used to handle error messages. There we go. It's going to be, of course, a use effect. It's going to have a callback function. And it's going to be changed whenever the error message changes. This is a new use state field that we're going to create. So right here, we can create a new use state field called error message. And it's going to be an empty string at the start. Great. Now we can pass that error message and set error message as values for our context. So that's going to be error message, as well as the set error message. Now back inside of the battle, instead of console logging the error, what we can do is we can get the set error message from the context. There we go. And we can now simply set it. So instead of console logging the error, we're going to call the set error message and pass the error in. Now, what's going to happen once we do that is this use effect is going to be recalled. So inside of here, we can check if the error message exists. So if error message, in that case, we want to parse it. So what we can say is const parsed error message. That's going to be equal to error message question mark dot reason question mark dot slice. And then we want to slice it from execution reverted. And then a space, and then dot length, and then slice from 0 to -1. This means that if we again open up the inspect, but now it's going to be gone because we are not console logging it anymore. If we have a string that looks like this, execution reverted, this is an error message. What we have done right here is we have sliced it off the execution reverted because we have typed it here and we took the length of that string. So it's going to be 1, 2, 3, 4, 5, 6. Let's say it's about 15 characters. We cut those off. And then we are left with the error message, so we simply take it right here. Finally, we can say if there is a parsed error message, then we can set show alert. We can pass in the status as true. We can pass in the type equal to failure. And we can pass the message as parsed error message. Great. Now, if we click attack again, we of course get a white screen. So let's see what this white screen is all about. It seems like we have the dot length that slice is not a function. So in here, we are missing a parenthesis because we start with a slice and we want to close it right here. And we have an extra parenthesis at the end. So to put this in a new row so we can see it better, we have the error message .reason .slice. We take the length of this string, execution reverted, and then we slice it one more time at the end from that point to the end. Hopefully this makes just a bit more sense. With that said, now let's click attack. And there we go. You have already made a move. This is parsed straight from the error message that we get straight from the blockchain. Great. Now we can search for all instances of where we said console.log error, and we can replace them with this special set error function. So we had it once right here. That is in the battle page. So let's do the same thing we have done already. That's going to be get the set error message from the context, and then simply, instead of console log, call the set error message. Let's repeat that for the create battle page. So one more time, we're going to get it from the context, and we're going to simply pass it here instead of console logging it. And I think we have to do that one more time. This is going to be in the join battle. We get the set show error, or rather set error message, and then again, we can pass the error in. Great. So now all of our errors are handled. If we try to defend or anything like that, we have already made our move. Great. Now it's our time to move to a second account. And we can see that the opponent is account 2. So now if we move to, that's going to be account 2. Again, core is still in its beta, so there might be some issues. And one of these is that it's opening a lot of different windows. So you might have to close some of them off. and then approve. But again, the reason why I decided to use it is because it's much faster than MetaMask. Great, we are now joined in by account 2, which has a huge attack in this case, 9-1. So we definitely want to attack with this player as well. But before we attack, I want to fully explain the rules of the game so that you understand how the game works in its entirety. If we open up our sidebar, we have some rules right here. I'm going to change the background to something darker so we can better see the rules. There we go. So cards with the same defense and attack points will cancel each other out, which means that if one player attacks and the other one defends, then we're going to cancel it out. Then, if they're not the same, attack points from the attacking card will deduct the opposing player's health points. So if this player attacks with 9, and this one, let's say, also attacks, then we're going to deal 9 damage to the 25 health. If P1 does not defend, their health will be deducted by P2's attack. So it's simple. If this player attacks and this player attacks, they both attack each other and deal damage straight to the health. If player 1 defends, player 2's attack is equal to player 2's attack minus P1 defense. That means that if this player has attack of 9 and this one has a defense of 5, then the total damage dealt is going to be 4. 9 minus 5 is 4. If a player defends, they refill 3 mana. If a player attacks, they spend 3 mana. And of course, both start with 10. Hopefully, the rules are a bit more clear now. So, before we finally make a move, we're going to go back to Avax Gods and we're going to explore the most important function in the entire smart contract, the result battle one. It happens after both players have made their moves, and in here we have to calculate the outcome of the battle. So let's go through it. First, we initialize a player 1. Then we initialize a player 2. We get all of their values, their health, their mana. We also get the attack values and defense values. Then we create a new array called damaged players. We want to know if the player has been damaged because later on we can use this to then show the explosion animation to let the user know that their player has been damaged. And then in here, with a series of if statements, we explain the battle functionality. If player 1 move is 1, meaning attack, and player 2 move is equal to attack, then if player 1 attack is greater than or equal to player 2 health, then we end the battle. So this is the final case, if we are doing that finishing blow and ending the battle. Also, if player 2 attack is greater than or equal to player 1's health, we are also ending the battle. Else, since both players are attacking, we can simply decrement the player health by the opposing player's attack. And we also want to deduct both player mana bars. If player health and defense are lower than or equal to attack, then we end the battle. Else, we check if the defense is greater than attack, then the health is going to remain the same. Else, health is going to be deducted by the attack. And in here, we have the same functionality, but just for the different player. One is defending and one is attacking. Finally, if both players are defending, nothing happens. And then at the end, whatever happens, we want to emit the round ended event, which is great. And finally, we have some resets. So we want to reset the moves to 0 so they can attack again. And then we want to again reset random attack and defense strengths. This is a function that's going to generate a random number, and it is quite complex. We use this function to generate a random hash to get a random number that is based on the block difficulty and block timestamp, and we generate a random value. Great. With that said, we learned how the game functionality works. But also, we saw that we are emitting a special round-ended event, which we can make use of on the front end. So let's go back to create event listeners and let's implement the listening for the round-ended event. The round-ended event listener is going to be the most interesting of them all, because in here, we'll be triggering sounds and animations. So let's say const round-ended event filter is equal to contract.filters.round-ended. Then we can copy this add new event, paste it below. We have to pass the round-ended event. Let's replace the battle move for round-ended event. And we can console log round-ended. We can also console log the args and the wallet address. Now, let's figure out who was damaged. We want to explode the player that was damaged. So let's create a new for loop. Let's say let I is equal to 0. I is less than args.damaged players dot length, and then I plus equal to 1. So we're looping over the damaged players to check who exactly got damaged. So let's say if args.damaged players I is not equal to, and we have to compare that with an empty wallet address, which is 0x and then a lot of zeros here. So let's take that variable and let's put it all the way at the top. I'm gonna make your life a bit easier. Down below in that same GitHub gist, you'll be able to find an empty account.js file, and it's going to contain just one line, this empty account address. So just copy it from the GitHub gist down below, and then you can use it right here. If damaged players I is not equal to empty account, that means that somebody must have gotten damaged. But if the damaged players array is equal to an empty account, then that means that nobody got damaged. So what we can do there is we can simply play the audio and then play the defense sound. That's gonna mean that nobody got damaged, and we're gonna hear that shield sound, which means that everybody defended successfully. But if the players did get damaged, we have to figure out who. So right here, we can say if args.damaged players I is equal to wallet address, meaning is it our currently connected wallet address. In that case, we're going to call a special sparkle function. And this function we haven't yet imported. So at the top, we're going to have to import those animations from our animations file. So let's say import play audio sparkle coming from /utils/animation. And we also have to get the defense sound. So we can say import defense sound coming from /assets. Great. So if we check that sparkle animation, that was that cool animation from the code pen above that I was showing you at the start. We can check it out one more time. If we click right here, we can see the animation. And that's exactly what the sparkle is. Just this time, we're calling it on demand, programmatically, once a player gets damaged. So we can call the sparkle function right here. But the question is, how are we going to know where to put the explosion? So for now, let's simply leave this like this, empty. And let's also add an else if saying args.damaged players I is not equal to wallet address. In that case, we want to explode the other player because it's not us. So we can call the sparkle, and that's it. But now, of course, we'll have to pass different properties into these functions depending on which one do we want to explode. So let's do that right now. We can go inside of our index and scroll all the way to the top. There, we need to create two different refs, use ref hooks. So that's going to be const player1 ref is equal to use ref. And then we want to duplicate that and create a player2 ref. Now we can use those references and pass them through the context. So that's going to be player1 ref and player2 ref. Now inside of the battle page, we can get those two props right here at the top. That's going to be here, player 1 ref and player 2 ref, and we can make use of them. Remember, we already created an empty spot for where we need to put it. So if we scroll down, card, card, ref. The first card on our list is player 2 because they're appearing at the top. So we can pass the player 2 ref. And then for the second card, we can pass the player 1 ref. Great. So that value is going to get passed all the way from the battle page to the index, which can then pass it to the create event listeners. So let's see, where are we calling the create event listeners? From inside of the index, it is right here. And we can now pass the player 1 ref and the player 2 ref as well. We can now open the function inside of the create event listeners, and we can accept player 1 ref and player 2 refs as props, or rather just regular function parameters. Now on top of that, we'll have to create another function, const get coords, as in coordinates, and that function accepts a card ref. There, we want to get current coordinates from the card ref, and we can do that by saying const left, top, width, and height is equal to card ref dot current dot get bounding client rect. This function gives us the current left and top properties, as well as the width and the height of the div. Finally, we want to return page x is equal to left plus width divided by 2, and page y is equal to top plus height divided by 2.25. I found these values to work the best, and they most precisely show the animation right on top of the card. Finally, we can go back to our round-ended event, and here we can call the getCoords function right inside of the sparkle function, and there we can pass the player 1 ref, and finally we can pass the player 2 ref as well. Player 2 is going to go down here. And of course, they shouldn't be inside of an array sign, so let's remove that right here. We're just passing that in the getCoords function. Great. Now that we have created the round-ended event filter, we're finally ready to test out the battle. So finally, let's expand the browser to its full glory. Let's also open up the inspect element. Let's put it to the side, and let's switch it to the console so that we can look at all of those great console logs from our listeners. Let's go ahead and attack from our account too. There we go. A new core notification appears, and I'm going to click approve. Alert of initiating attack just appeared, which is great, but keep in mind this does take a couple of seconds. So we should be able to see a console log right now, hopefully. And unfortunately, nothing happened. So let's try to reload the page. And as you can see, it still has 9. The health is still 25, and the mana is 10, which means that nothing really happened. Let's try clicking attack again. And let's try to click approve. Again, it says initiating attack, but nothing happens after that. Is it possible that we're getting some kind of an error, but we're not really seeing it? Well, let's test it out. Going back to the code, we want to see where we're calling that attack function, and that is going to be inside of the battle. So we can go right here. There we go. Make a move, contract, attack, or defend choice, and we're also setting the error message. Let's also console log the error, just in case. And let's try to attack one more time. I'm going to click approve. We do get initiating attack, which means that this function ran successfully. So it's not this error that we're expecting, but it looks like after I reloaded the page, the attack and defense values got regenerated, the opposing player attack lowered by 9, which seems that the resolution of the battle worked, but just not instantly. And that's the reason why we have created that set update game data function. So have we already used it here? Let's take a look. Inside of create event listeners, I think we have used it. There we go, set update game data. And we can now copy that and use it right here. So after something happens, we want to immediately update the game data. Now to test the functionality, let's one more time expand the screen and let's attack from account 2. Attack is 6. I'm gonna click approve. It's gonna say initiating attack. There we go. We have a battle move initiated to true. And now I'm gonna switch back to account 1, reload the page. And from account 1, I'm gonna attack as well. And I'm gonna click approve. Now we should be able to see initiating attack, then we should see battle move, and then a battle resolve, or rather a round ended. And there we go, that's exactly what we got. Round ended, we can see damaged players. In this case, both of them were damaged, but it looks like we have a problem with the get bounding client rect. So if we go back to the code, that's going to be inside of the get chords, card ref dot current dot get bounding client rect. This is looking good to me. Let's see if we're passing the card ref. So if we go right here, it seems that we are. So one more time, let's check if we're properly setting those values. We have created new refs, player 1 ref and player 2 refs. Then we have passed them through the context, player 1 ref, player 2 ref. Then inside of the battle, we have extracted player 1 ref and player 2 ref. And then we have added them to these cards, card ref and also card ref here. Let's dive into the card. And it looks like we didn't use the card ref here. That's because we were getting an error before, but now we do have the ref, so we can say ref is equal to card ref. Great. Now we can go back to the game, and let's try to attack again. This time, I'm gonna attack with 3 on JS Mastery. Now I'm gonna reload the page. There we go, the changes happened. I'm gonna attack with 9, which is huge again for JS Mastery. We're gonna wait for that move confirmed. There we go, battle move initiated. I'm gonna move to account 2, reload the page, and I'm gonna attack with 6. Since both of the players are attacking, once the battle is resolved, I'm hoping to see explosion on both cards. And there we go. A sound and the explosion animation happened and the round ended. You can also see that our health bars are working perfectly. It's bright red here and it is orange right there. Also, mana was deducted for 3 different attacks. So now it's down to 1 and also the values are being updated for every single round. Now, of course, both players have to defend to regenerate their mana. So I'm gonna defend with account 2, click approve. I'm gonna move to JS Mastery, reload the page, and I'm gonna defend as well. This time, once the battle is resolved, we're hoping to hear the shield sound and no animation. And there we go. That's exactly what I got right now, and hopefully you got it as well. Now, let's hope that we can finish the battle in the next move. I'm gonna attack with JS Mastery, but I'm not gonna kill the opposing player. But if we switch to account 2 and reload, we can see that their attack is set to 7, and the opposing player health bar is set to 4. So if they haven't defended, and they didn't, we can now attack and finish the opponent. Unfortunately, JS Mastery is losing here, but that's good. No worries there. I'm winning just by providing you with all of this free knowledge. So let's see what's gonna happen. round ended event. There we go. And now, if we reload the page, the battle shouldn't exist anymore because it should be done. So there we go. As you can see, all of the values are empty and the health bars are set to undefined. Of course, now is our turn to actually redirect us back to the home page and allow players to start new battles. Isn't this great? So I'm going to collapse this. We're going to go back to the battle page and we're going to add a new use effect to check if the game has ended. So that's going to be use effect. It's going to be a callback function. It's going to happen only at the start. There, we want to add the timer. So const timer is equal to set timeout. We're going to create a callback function. In here, we're going to check if no game data ?active battle. And if that is the case, we're going to navigate to /. So we're going to wait for 2 seconds, see if maybe something got wrong, and then only if there is no data after 2 seconds, then we're going to go back to homepage. Of course, for the timer, we have to add an array here and set it to 2 seconds. Finally, in React, it's always good to clear the timers, so we can say return a callback function where we're going to call the clear timeout and pass in the timer. Now, as soon as we reload and wait for 2 seconds, you can see that we are redirected back to the homepage. Isn't that beautiful? With that said, we have done a lot. We have a create a player page, create a new battle page, join existing battles. We have a choose a battleground page, and we also have that beautiful battleground where you can actually battle with other players in real time. We have done a lot of things, but there are still some final checks we can do. It might be cool to do a real game, to open 2 browsers side by side and to see how the game works in its full glory now that the main functionality has been completed. So for now, I'm gonna close all of the currently open tabs. I'm gonna expand this to half a screen, and we can also open up a new browser. Now, if you open up a new tab in the same browser and then try to switch to a different account with one specific browser, for example, I switched to JS Mastery here, but then I'm gonna switch to account 2 on this browser, that's not gonna work because it's gonna switch here as well. So we cannot really replicate a battle, but there is one workaround. If you click on your account here in Chrome, and then you can add a new profile. In this case, I created this dummy cat profile. And now you have an entirely new browser you can test things with. Inside of this browser, you also have to install the core extension and follow all the same steps that we have already gone through. So if you forgot how to install the core extension, make sure to do that. You can go to the Chrome store, search for core, download it, and then you have to go through the security steps of making sure that you write down your passphrase. After that, copy your address, go to the AVAX faucet, get to AVAX, and then you're ready to battle. So now we have one wallet. You can name it however you want. In this case, I named this one React.js. And then on the other one, we can have JS Mastery or your name as well. And with that, we can actually create the battle from one account and then join the battle from a different one. And that's exactly what we're gonna do right now. Let the battle begin. In this case, since JavaScript Mastery lost the last round, he is salty and he wants to win the next one. So he's going to create another JSM's Battleground. And let's create a battle. We immediately get a notification to create a battle. And once we do, we're waiting for an opponent. But now, if we go to join already existing battles and reload the page, we can see that the JSM's Battleground immediately appears right here. So let's join. In this case, you also have to register a new player on your new browser. So I call the account React.js, so I'm going to call the player React.js as well. Feel free to call it however you want to. And let's register. I'm going to click approve. React.js is being summoned. That's cool. We should get redirected to the create battle page. There we go. Player has been successfully registered. Unfortunately, there was no redirect. So maybe that's something we missed. If we go back to our code editor, and if we go to the homepage where we create a player, in here, we need to have a check to move to the create battle page once the player has been created. Let's reload the page, so maybe then the player gets redirected. And that is the case. We are on the create battle page, and let's join an already existing battle. And there we go. JSM's Battleground is right here, so let's join. We're gonna get a notification, and let's click approve. Joining JSM's Battleground, an alert is there, and in a couple of seconds, we get redirected, and also the loading screen disappears on the second player screen. This is great. On one hand, we have React.js, and on the other, we have JS Mastery. In this case, React has 3.7 and JS Mastery 2.8. So let's play. Let's also change the battleground a bit. So let's do this green one in this case. So in this case, let's say that React decides to attack and JS Mastery decides to defend, because they have such a high defense number. There is some strategy involved in this game, because you want to keep track of your mana. If you keep attacking, you're losing your mana, which is not good. Now, in this case, it looks like a defense didn't go through properly, so I'm going to click again, and I'm going to click approve. Initiating defense. And there we go. I heard that defense shield sound, which means that nothing happened. In this case, let's say that both players attack. JS Mastery has a really high attack of 7. I'm going to click approve, and I'm going to attack with React.js as well. So we can see initiating attack on both sides. JS Mastery should damage React.js by 7 points, so the health should drop to 18, and we should see 2 explosion animations. Unfortunately, it seems that the attack didn't go through on the left side, so I'm gonna do it one more time. It looks like if we're doing attack really closely one to another, then it can get stuck. But now that we've repeated it, we've seen those explosion animations, and the health got deducted. Great. Now we're not gonna play this game all the way through. Before that, we want to finalize the exit battle functionality. So that's going to be our next task. And then later on, once we exit and once we implement that, we're going to do one entire wraparound, the entire application. We're going to explain the most important functionalities one more time, and then we're going to check if we still have any errors, warnings, or if something is not working as it should, as is the case when both players hit attack at similar times. So exit battle is going to be next. For now, I'm going to close one browser. I'm going to close this one as well. And I'm going to open the Visual Studio Code. Remember, we had our game info component, and that is where we had the exit button. We, for now, left that function as empty. So implementing the logic inside of the handle button exit is going to be our next job. And now that we already know what we're doing, this is going to be pretty easy. We can first get the battle name by saying const battle name is equal to game data dot active battle dot name. We can open up a try and catch block. In the catch, we're going to have an error. And we can call await contract dot quit battle. And we have to pass in the battle name. We can quickly go into the Solidity contract and search for quit battle. This function is pretty simple. We first get the battle. We have to make sure that the player trying to quit the battle is the one that's inside of it. And then finally, we call the internal end battle function. This function resets everything. It sets the status of the battle to ended. It sets the health and mana to 25 and 10 respectively. It sets the in-battle status of both players to false, and it sets out the battle loser. Finally, it emits the battle ended event, which we have to keep track of inside of our game info, which we are yet to listen for on our front end. So right here, let's set show alert. We can set the status to true, type to info, and message to you're quitting the, and then we can give it a battle name. Of course, this right here is a template string, so we can make it as such. For the error, we can import that set error message, and we can call it right here and pass in the error. Great. So now we can quit the battle. But before we do that, let's first add a listener for the battle ended event. For that, we can go into the create event listener function. And right here, we can add our final event listener. We can copy those two lines we always use, paste them here. Instead of round ended event, this time it is going to be battle ended event filter. This only happens after one of the player's health bars reaches 0. And in here, we have to change this to battle ended. There we have a function, and we can set a console log equal to battle ended, and we can console log the args and the wallet address. Finally, and most importantly, we have to say if wallet address dot to lowercase is triple equal to args dot winner dot to lowercase. If that is the case, that means that we are the winner. So we can set show alert. We can set the status to true, set the type to success, and set the message to you won. Then we can do an else if and check if wallet address dot to lowercase is triple equal to args dot loser dot to lowercase. In that case, we want to again set show alert, which is going to be status true, type failure, and message is going to be you lost. Finally, in any case, meaning outside of this if and else if, we want to navigate back to create battle. Great. With that said, our exit functionality should be done. So if we try to click exit, we get a notification. Let's click approve. You're quitting the JSM's Battleground. And we got the you lost, which is exactly what we expected. Now the game should have ended, and if we reload the page, we get back to create battle, which is great. With that said, most of the game's functionality is now completed, but I always like to take it a step further and make sure that everything is working perfectly and that you fully understand what you built in this video. So let's close all of the files and folders. And right now, we're going to do one final sweep through the entire code base, add the missing pieces to make it even more perfect, and I'm going to re-explain the most important functionalities so you take away as much as possible from this video. Let's start with our fixes from inside of the Create Event Listeners page. Inside of here, we created event listeners for new player event. We also have a new battle event. We have a battle move event, round ended event, and finally the battle ended event. So as you can see, quite a lot of different events we're listening to, but we forgot one. And that one happens right after we create a new player. So first we create a player, and then immediately we create a new player token for that player. So right below the new player, let's say const new game token event filter. Now that's going to be equal to contract.filters.new game token. And we can copy this opening line, paste it here, and we can also properly close it. Now, of course, this is not going to be new player event filter. It's going to be new game token event filter. We're going to get the args, and we can put a console.log right here. We can say new game token created, and we can also console log the args. Inside of here, we want to check if wallet address dot to lowercase is triple equal to args.owner.to lowercase, meaning is the account we are currently connected to the account that we created the token for. If that is the case, we want to set show alert, and inside of here, we're going to set the status to true. We're going to set the type equal to success, and we're going to set the message equal to player game token has been successfully created. There we go. And one more important thing we have to do is below that, we're going to add a navigate function, and we're going to navigate the player to create a battle. Because once the player is registered and once they have their game token, then they can create a battle. If you remember correctly, about 10 minutes ago, while we were testing the game on the other browser, and when we created a new account, we weren't redirected from the home page to the create battle page. But now this event listener is ensure that that happens. So we have a continuous flow of our application. Great. That was one fix we needed to make. Now another fix is going to happen inside of the index.jsx from inside of the context. Here we have the update current wallet address, and this function is being used in this use effect. It's happening at the start. It's also happening when we change accounts. But we also have to pass that function through context values right here, update current wallet address, because it's being used in the onboard modal. So if we dive into the onboard modal, you can see that we are getting the update current wallet address, and it's being called if we haven't yet connected our core wallet. Then we can do that right here. So that was just one little fix that we needed to make. Next fix is also going to have something to do with redirects, and that's going to be inside of the homepage. Right here, we have a use effect that checks for the player token, and if that is the case, it redirects to the create battle. But what would happen if a player already has a game token, but not only that, they are already in the active battle? In that case, we want to redirect straight to the battle page. So below this use effect, we can add another use effect. This use effect is going to be a callback function, and it's going to happen once the game data changes. We can say if game data.active battle, in that case, we want to navigate to a template string of /battle /game data.active battle.name. Now, if we are in an active battle and we try to go to the home page, we will immediately be redirected straight to the battle page. In this case, it looks like something breaks, so let's open up the console, and it looks like game data is not defined. Thank you, console. Now we can go back and we can get the game data from our context variables. There we go. And as soon as we fix that and reload, we can see our homepage. Another thing I can notice is that in here for the error, we are using the set show alert. Remember, I told you we're going to come back to this. So instead of that, we can use our own set error message function, which is also coming from the context. So let's say set error message. And finally, instead of showing the alert, we can call the special set error message, pass the error, and then that's going to immediately call the failure alert. Now, if we reload, this is looking good, no errors there. So now the homepage is good. But what if the player is in the join battle page and they are already inside of a battle? They cannot join another one, right? So we have to handle that edge case as well. There, we need to add another use effect. This use effect, of course, is consisted of a callback function and a dependency array. And then in here, we also need to get the game data. We can say if game data question mark dot active battle question mark dot battle status is triple equal to 1, meaning do we have an active game, then navigate to a template string of /battle /game data dot active battle dot name. Perfect. Again, handling an edge case. If we are on the create battle screen, but we're already inside of a battle, then we cannot join another one. Rather, we should be instantly redirected to the battle we're already in. And finally, I think the most pressing error that we currently have, or rather a small bug and an inconsistency, is inside of the battle page. Remember, while we were testing the game live, sometimes attack and defense functions were not being executed. Even though the logic is perfect, we're calling the make a move, which then calls a contract. Sometimes you saw we had to double press the attack or defense for it to affect the contract and therefore affect the game. After doing some digging, I think I might have figured out what the problem was. So go to Files or to Explorer, go to the index.js of the contract, and then copy your address. Then go to testnet.snowtrace.io and paste the address of your contract right here. This is going to find your contract on the blockchain, and there you'll be able to see all the transactions we've been making while testing our application. You can see that sometimes these transactions fail for some reason, and it looks like the most common error is transaction out of gas. So if we open it up, you can see, warning, error encountered during contract execution, out of gas. And if we look into it, it looks like the gas limit was set to 87,000. Now, we have a lot of AVAX tokens. We don't really care about wasting some for the gas. So what we can do is we can increase the gas limit, which is going to ensure that every single transaction passes. So what we can do is go back to the battle page and we can pass one additional parameter to our contract. Every single function has a couple of parameters. For example, our attack or defend choice has two, the choice and the battle name. And we can quickly see that if we go to the Solidity contract and search for make a move, or I think that's going to be attack or defend choice. So if we search for that, you can see it has 1 and 2 parameters. Some other function, for example, register player, has 1, 2, and then 3. Now, what happens is when calling contract.some function, after you pass all the parameters, you can pass a special options object. This options object allows you to pass the gas limit right here. So in this case, we're going to pass the gas limit of 200,000. That looks like this: 20, 200, 2,000, 20,000, and then 200,000. Now, we can do this for our attack or defend choice, but we can also add it to our other contract functions. So let's simply copy this object and let's search for contract dot. And then we can find all other instances of our contract, and we can also add a comma and then pass the gas limit. That's going to ensure that all of our functionalities work. Let's see. There we go. These are fine. We can do it mostly for the most important functionalities. So that's going to be create battle. We can pass it there. Make sure to add a comma. That looks like this: await contract.create battle, and then you just add an object that has the gas limit of 200,000 at the end. We can also add it to the register player right here. There we go. And we can add it to join battle. Great. I think this is going to be it. And with that said, we have fully completed our game functionality. So I'm going to close all of the files and we can open it up in the browser. There we go. Here is our game. In this case, we have already created a user. So immediately, if we try going back to /, it's going to redirect us back to create battle, which is great, which means that the flow of our game works. You've done a lot of work to build this application, and I want to congratulate you for doing that. Phenomenal job. Not a lot of people can say that they have built their own blockchain, Web3, NFT battle style card game. Congrats. Now, let's go through the functionalities of our app one more time so you can explain the code base to your friends or potential employers. You always need to know what we did in this video. So while we were starting, we created a new Web3 folder. There, we initialized the application using Hardhat. That created the config for us. It also created different scripts. And finally, we had to code our own AVAX Gods contract. Throughout building this application, we explained most of the functionalities of this smart contract, from creating game tokens, creating random numbers, creating players, registering everything, and so much more. We also learned how we can emit different events from the smart contract and then listen to them on the front end. Finally, we connected our application to our front end using a package called Ethers. Right here, we are importing Ethers. And then finally, inside of one of these use effects, this one right here, we are connecting our wallet to our smart contract and creating an instance of that contract so that we can call it later on. Finally, we created a huge context file which allows us to have access to all variables inside of our app, and it acts as a one source of truth. Finally, we created a beautifully elegant page higher order component. You can see that we are using this and passing components into it. So our components, such as the homepage, which you can see right here, also the create battle page, which we can see right here, join battle page, and many others are using our higher order component to render this great page. Finally, we are jumping into the battle. There we use the beautiful background image, and then we have this make a move functionality where we're playing the audio and dispatching different contract functionalities so that we actually make the changes on the blockchain. Great. With that said, we can now deploy our application so that you can play the game with your friends online when the application is live on the internet. Believe it or not, deploying this app is going to be much simpler than you might think. If you want to use this game to deploy it on the internet with a custom domain, put it on your portfolio, share it with people, with potential employers, play it with your friends, I would highly suggest getting the Hostinger's domain and hosting. Right now, they have a crazy up to 40% off 4-year hosting plans plus free domain. The link to a discount code that's going to give you an even bigger discount is in the description. If you're watching this while the Black Friday deal is up, then I would suggest you immediately picking it up. But even if you're watching it later on, they have incredibly affordable prices. Again, the most important benefit of using Hostinger here is that you're going to get a free domain name. So you can do something really cool like give a name to your application like avaxgods.com or something like that. You can use something completely custom and something that resonates with you and your app. And don't forget, if you want to get an even higher discount, the link is going to be down in the description. Now, my goal with this video is to make everything accessible to every single one of you. So in this case, we'll be using Netlify. To deploy our app using Netlify, go to netlify.com and then log in or sign up. Once you're there, go to Sites. And now we are ready to simply drag and drop our website. Let's collapse this window. Let's go to View and then Terminal. We're going to stop our application from running by pressing Ctrl+C and then Y. Clear the terminal. Make sure that you are inside of NFT card game client, and then I'm going to run npm run build. This is going to create an optimized production build so that we can use it right inside of Netlify or Hostinger. There we go. If we open up the Explorer, now we can see that a dist folder appeared. We can click Reveal in File Explorer or Finder if you're on Mac. And you can simply drag and drop the dist folder right here. And there we go. Let's expand this. As you can see, the application has been deployed. And if you click this link, Would you look at that? We get a new core notification because now we are on a new domain. And if we close it, and we immediately get redirected to the create battle page because the blockchain and the smart contract address are still the same. So it remembers our player from our local host, which is great. But if you send it to new people, they will have to connect their wallet and create a new player. With that said, our app is live right here. Again, the only difference between Hostinger and Netlify is that with Hostinger, you're going to get higher speeds, and also you're going to get a custom domain so that you can have it much shorter and exactly as you like. Great. With that said, I think it is the right time to do one final test of our entire application. So let's close all of the tabs and let's open up our browser on the other account. If you try to paste this URL with a /create battle right here, you're going to notice that we have a page not found. And also, if you try to reload the page here, you're going to also get the page not found. A quick Google search is going to let you know to add the _redirects file to the public or the dist folder in your code. So let's go back to the code. Let's go to our dist and let's add a new file called _redirects. And finally, in there, we can type /*, and then /index.html, and then finally 200. This is going to fix the problem with the reload. So what you have to do is go back to Netlify or Hostinger, go to deploys, again, open the dist folder in File Explorer, and redrag and redrop it. In just a couple of seconds, the new production should be published. You can click on it again. We can close all of the other URLs. And now, if we reload the page, the other browser opens up as well. And if we reload, you can see that everything works. That was that one little fix that you have to do when publishing the application on the internet in case you're using React Router DOM. And I'm really glad issues like these happen because that's how development is. And if you're building this on your own, you could have spent hours and hours trying to figure out why do you get a 404 after a reload. It worked on your machine locally, right? So why is it happening? And that's the main reason why I always leave these errors right inside of the video. That way you know that everything is not always perfect, you sometimes have to debug things, and I want to teach you how to debug them properly. If you like that approach of teaching, I would highly suggest checking out the JS Mastery Pro courses. Currently, you can choose between Filmpire and NFT Marketplace, which might be an interesting fit as you're already learning how to build Web3 applications, but this time we're going to dive deep into the Solidity side of things. That's going to help you understand the contract we wrote in this application so much better. Also, if you want to really accelerate your learning and you like my approach of teaching, you're gonna love the masterclass experience. It is a complete bootcamp helping you to land your dream job in 3 to 6 months. We're starting with the next cohort in January, so if you're interested, make sure to take the quiz to make sure you're eligible, and then we're going to invite you when we're starting with the next cohort. With that said, let's give this application a go. This time, maybe React.js can create a battle, so let's reload, make sure that we are connected to the application. I'm gonna approve. There we go. I'm going to create a battle and call it React versus JavaScript. And I'm going to click create. We get a notification and I'm going to click approve. There we go. We are waiting for an opponent. While we're waiting, we can choose a battleground. Let's go with Astral. And on the other screen, we can join an already existing battle. Let's reload the page. There we go. And I'm going to click join and approve. We are joining the battle. And both players got redirected to the battle screen, which is great. Now on the right hand, let's change the battleground to this one. Just to make it a bit different, we can see that all players have 25 health and 10 mana, and also that the attack and defense values have been randomly generated. Finally, let's attack from both players. We hear that great notification, and we can see initiating attack on the left side, and hopefully also on the right side. Now the changes are being made to the smart contract. We immediately got those huge animations as well as explosion sounds, which is great. And the values got regenerated. Also, you can see the health changed. Now, looks like JS Mastery has a lot of defense. So in this case, we're going to choose to defend. And let's say that React also wants to attack. Initiating defense on the right side and initiating attack on the left side. And I didn't see initiating attack on the left side, so I'm gonna do it again. There we go, initiating attack, and now we can wait for the battle resolution. We just heard that shield sound, which is great. In this case, let's say that both players attack one more time. Looks like React.js has huge attack, so that's gonna do a lot of damage. There we go, the values have changed. Unfortunately, I paused the recording, so we missed the animations, but they did happen on my end. And right now, it looks like React.js has a huge attack, 9-1, but also he has 1 mana. So that's not quite good. You always need to have at least some mana in case a huge attack shows up. That's a strategy tip that I want to give you. So in this case, we have to defend because we cannot attack as we don't have enough mana. So let's do that. And coincidentally, JS Mastery got a huge attack, but they do have the mana. So we're gonna attack. Now only React.js should explode. And that's exactly what happened. We can see that the health dropped to 6, which is quite low. Now, let's say that React.js attacks again with 3, and JS Mastery is also going to attack with 5. Both players got damaged. JS Mastery is on 8th health, and React.js is on 1. So now both players have to defend because they don't have enough mana. So let's click defend on React.js and defend on JS Mastery. And let's wait a moment. There we go. We got that sound. And now it looks like JS Mastery has 6 attack. The health is 1. So if React.js chooses to attack, and if JS Mastery chooses to attack as well, JS Mastery is going to do that finishing blow. So we should be able to see you won on the right side and you lost on the left side. Initiating attack. And there we go. You won, you lost, the values got immediately reset. But now if we reload the page, you can see that we get redirected back to the create a new battle page. That is beautiful. Everything now fully works. We can expand one of the browsers and we can admire the application we've built. And finally, huge thanks to Avalanche, not only for sponsoring this video and allowing us to build this application so that it acts as fast as it does with their software. Otherwise, we definitely wouldn't be able to do that, but also for building such a phenomenal platform that allows you to scale your Web3 dApps. With that said, we've came to the end of this video. Huge congratulations for building it through, and I hope you're gonna love putting it in your portfolio, playing it with your friends, and sharing it with your potential employers. With that said, if you haven't already, check out the JSMastery.pro platform for professional courses, and that's going to be it for this one. Have a wonderful day.